Good morning, everyone. The topic of my lecture is earthquake safety of precast buildings. So, I'm going to discuss the following items. First, background of earthquake problems vis-a-vis precast constructions and earthquake problems in the country, behavior of precast buildings, design standards, and way forward. So, India has witnessed significant earthquakes in last two centuries, and in last 3 decades we have had many moderate earthquakes. So especially Uttarkashi, Latur, Jabalpur, Chamoli, etc. And if we look at these earthquakes, it has caused immense loss to property as well as life. So when we look at vulnerability, so collapse and damage to buildings in the country is unreasonably high compared to any other country with similar level of ground shaking. So in this regard, there is an urgent need to understand housing risk as well as minimize future losses of life and property. So let's look at earthquake risk in the country. So risk is composed of these three factors, that is hazard, exposure, and vulnerability. So hazard means level of ground shaking which an area will experience, and exposure is number of buildings exposed to such an hazard, and vulnerability is the capacity of the building to sustain that earthquake shaking. Now, if we look at hazard, so according to IS 1893, so India is divided into 4 zones, that is zone 2, zone 3, zone 4, and zone 5. So zone 3, 4, and 5 put together is that area is in moderate to severe earthquake events, a moderate to severe earthquake prone area. So around 56% of Indian land is prone to that area. And unfortunately, our 80% of population is spread in that 56% of land. So it means 4 out of 5 people are under earthquake threat. So if you look at this map that is earthquake threat factor map. So this is hazard plus exposure. Both are overlapped on each other, and we have this. So in this map, we can see each red patch. So red patch. So each patch is one district, and these red patches are the areas of focus. So we need to consider these areas on priority basis for reducing the earthquake losses in the event of future earthquake. Now let's look at the housing stock. So in India, still largely individual houses are self-built, and we call these buildings as non-engineered structures. And earthquake performance of these buildings is known to be very serious. That is, it is not acceptable. So these buildings will usually collapse. So there is a grand challenge for housing. So technically complex and also need state-of-the-art technologies. We need world-class knowledge and skills. So in this area, precast construction is really a boom to the construction sector right now. So and during this COVID era or post-COVID era, there will be definitely a big challenge to boost up this construction activity. So now let's come focus on precast structures. Now, what precast constructions are addressing? What precast constructions are addressing? So if we look at this one, now it is addressing the problem of mass housing and faster constructions and also manpower issues. But the issues which it need to address, okay, that is another 3 important things. One is cost effective, and then socio-cultural issues, and then most importantly the safety. Safety is the important concern in when it comes to precast. Now, why I'm saying this, let me take you to the earthquake behavior of precast constructions. Now, this is after Chile earthquake. So, building has been collapsed. It is like tilt-up panel due to weak wall and roof connections. And then you can see this double T panels so could not behave appropriately during earthquake. And say a parking garage in Miami Dade College. So weak performance during earthquake. And then this is a school building collapse in Gujarat during Bhuj earthquake. So in fact, Gujarat government has launched a massive program during 1999 and 2000, where 6,000 buildings were constructed using precast technology. So during this Republic Day earthquake, so 3/4 of these buildings were severely damaged. Over 1,000 school children, along with 30 school teachers, died. Actually, the photographs, the picture in the inset is the dead bodies. Okay. Now, when we look at world's best practices in the area of earthquake safety, so early 1900 there were very high human fatalities and high economic loss, and early 2000s low human fatalities and still high economic losses there. When it comes to India, even now also we have high human fatalities. So we need to address this one. So let's look at what construction or earthquake standards say world over and with respect to India. Now, if you look at say United States of America, there are ACI standards, NEHRP provisions, and PCI standards. And Europe also has the standards for precast constructions. Australia, New Zealand, Africa. So they're all working towards the safe and convenient built infrastructure. Now, this NEHRP and FEMA, they've given the regulations for new buildings and other structures, and untopped precast diaphragms. And then FEMA P751 provisions and design examples are given, especially in Chapter 8, that is precast concrete design for horizontal diaphragms, and PCI connections manual. So they give design examples for foundation connections, beam column connections, and double T to wall connections and wall to wall connections. So these are worked out examples to understand how to design and execute precast constructions. Now let's come to Indian standards. So when we look at Indian standards, so the standard the code, that is IS 456, it is for plain and reinforced concrete. And then 1893, that is for criteria for earthquake resistant design of structure, and 13920 is for ductile detailing. Now coming to this prefabricated constructions, we have code 11447, that is a code number, and 15916, 15916 is the most recent addition. So this code says that precast structures are to be analyzed as monolithic. So this is where the issue is right now. So we need to address this one. Now let's look at some of the basics. So what is required is earthquake resistant, not earthquake proof constructions. So what does earthquake resistance mean? Okay, so it means the damage is expected. So when earthquake imparts energy into the structure, so it has to be dissipated from somewhere. So where the energy gets dissipated. So if you look at the strength hierarchy of structural elements, slab is supported on beams, beams are supported on columns, columns are supported on footings or foundation, and then to soil. So the one which is supporting should be more stronger than one which is getting support. So in this sequence, if we look at it, so soil failure we cannot allow, foundation failure we cannot allow, column is a stability problem if it fails. Now we have only two areas, one is slab and another one is beam. So slab will have a problem of functional utility problem. So now where the energy dissipation is allowed, that leaves us the only choice of beam. So when it comes to beam, energy dissipation is allowed in conventional structures in beam, so by way of plastic hinge mechanism. Now when it comes to precast construction, so where the energy dissipation will take place. Now if you look at this one, the upper curve, that is green curve, is depicting the ductile performance of the structure, and this red color is the brittle performance of the structure. So in fact the area under this curve is actual measure of energy dissipation. So that is very important. Now when it comes to precast constructions, so each precast panel, so when vibrated horizontally, so they rock instead of this bending behavior or shear behavior. Now when you look at the squat walls, they slide, and split walls, they rock. Now let's go to the fundamentals of that. So flexural behavior of elements have this equation of motion, that is mu double dot plus cu dot plus ku is equal to minus mug double dot. when it comes to precast elements, so they behave rigidly. So this equation itself is a nonlinear dynamic equation. Now, when we look at the earthquake resistant design, actually it's special when it comes to precast constructions. So this table shows that which element is offering ductility and what are the important challenges. So if you look at this red color highlighted one, precast building, so steel bars offer ductility, and then structural ductility can be good or it can be bad depending on the design of the connection. The main challenge in precast construction is the design of connections. So why? Because they have to offer ductility. So ductility is actually the capacity to take additional displacement without collapse. So we need to understand these four types of ductility. One is material ductility, cross-section ductility, member ductility, and structural ductility. So this, if we ensure this member and structural ductility, that is in between the two element, that is a joint, then we are safe with that. So the main challenge is that. So if you look at this hysteretic energy dissipation, conventional construction as well as precast construction. So in precast construction, the total area of hysteresis is significantly less compared to this monolithic construction. So this we need to achieve. So if, let us look at, say, experiments in terms of element and joint level experiments. Okay, let me skip these two slides. So these are several joints are present in this one. So we have three types of joints. One is rigid joint, second one is pinned joint, and third one is semi-rigid joint. Okay. So for earthquake safety, we need moment resisting joints. Now there are two types of connections. One is wet connected pieces, precast pieces, and dry connected precast pieces. So this is a typical example of wet connected pieces. Now let's look at, say, full-scale experiment. This is a small house. Okay. So wet connected experimental study under controlled conditions. So slab intact even when subjected to extreme earthquake load. So this is not our work, but from references I'm quoting these examples. Okay. And dry connected precast pieces. So they have poorly performed during past earthquakes. This is a Gujarat example. Okay, so analytical modeling is unsuccessful to emulate the dry connected joint. So hence we need to go for experimental studies only. So full-scale tests to be performed in laboratory since analytical methods are not reliable. So why we need to do is to understand the deformation capability. So ensure positive anchorage of precast elements with each other so that the energy dissipation is appropriate, and then it can be given as a good example for mass construction of housing. So in other countries also these experiments were carried out, so especially in Turkey. So research program was initiated in Metro University for development of beam column joints as moment resisting joints. And then European experiments, a full-scale testing of three-story structure, and ground motion was given up to 0.3 G acceleration, and they tested slab to slab, slab beam, and beam column, column foundation connections all were tested. So appreciable results are there. So in terms of this material test, there are two kinds. One is monotonic test, and then second is cyclic test. So under monotonic test, what we study is deformation capacity of these elements, ductility, and the damage capacity, and then in cyclic test, strength, energy dissipation, and energy decay. Now US also there was a test on this press building in San Diego, that is pseudodynamic test. Drift was registered up to 2.7% of height, and it was found that damage in this precast building is less than conventional structure. So this is a ray of hope for multi-story building constructions. Now, yeah, this is the test setup. So experimental setups in India. So we have national test facilities in the country. So one is at IIT Kanpur, the pseudodynamic test for full-scale building. In SERC Madras, we have there is a shake table available. In CPRA Bangalore, shake table, but this on this one we can conduct small-scale tests only. But IIT Kanpur, there is a full-scale dynamic test facility is available. So now the way forward in this is towards earthquake safety, there are four virtues of earthquakes resistant construction. One is configuration, strength, stiffness, and ductility. So in strength, stiffness, precast constructions fare well, but when it comes to ductility, especially the joint connections, this hysteretic energy dissipation has to be proved. So for that, we need more full-scale test facilities in the country to be developed and demonstrated. So the recommendation for mass housing is undertake full-scale tests before undertaking mass construction. So like with this, I would like to stop here. I'm very grateful to CIDC for invitation, and this is my contact details. So yeah, you can write if you have any questions.
Hello friends, this is Vivek Naik. I'm past president of Indian Concrete Institute and managing director of Apple Chemie India Private Limited. Today, we are on the platform of India Construction Week, which is organized by CIDC. I would actually like to appreciate the organizers and especially Dr. Swaroop and Dr. Bharadwaj for bringing out these things to us and putting a put forward a step in new technology. Now I am going to talk to you on innovative materials for sustainable construction. I'll be speaking on innovations and sustainable construction. If you are talking about innovations, successful commercialization of a product, process, or services as a part of demand of the market or a target customer is referred to as innovation. As far as civil engineering industry or construction industry is concerned, the definition is a little different. Let us look at what is sustainability and what is the innovations. I am giving you very simple examples. Recently, in the Discovery Channel, there was a sustainability appreciated, and wherein in Rajasthan, refrigerators were made out of clay. And in this refrigerator, except making ice creams, everything can be made, everything can be used. You can put fruits, milk, vegetables, and keep it cool. And there is no energy required, external energy required. And the refrigerator can cost as less as around 2,000 Indian rupees. And it's absolutely sustainable, and it has been appreciated all over the world. Similarly, if you're talking on the innovation side of it, I really have one example, which is of Tata Nano. Now, this particular vehicle has got innovations of 31 in the design part, 31, and around 37 patents on the technological front. So this is something great. Now let us look at what our construction industry has done on the innovation side. Yes, recently there is a huge mechanization, concrete mixers, cranes, power tools, they have come in a big way, computer-aided design, beam modeling system, modular construction, which is precast, prefab, and also robotic total stations. So this has changed the way we do the construction. Similarly, if you are looking at the pavements, concrete roads are being done everywhere in the world, and even there are precast, prefabricated concrete road panels. And the innovative part is that now people are even trying to put sensors in the lifting holes, and then there will be sensors, processors, which can transfer the information about the behavior of the concrete pavement. You can monitor it sitting in the office, and that is something great. If you are looking at the innovations on the resource side, yes, manpower, we are taking care of great. We are having smart clothing for the people who are at the site. This clothing can change its own temperature based upon the body temperature of a worker. And for the safety side also, if you are putting up these new gloves, which are developed recently in Germany, then the gloves will change its color if the person is touching his hand to any toxic product. So this is quite a safety parameter, I will say. On the site resources, smart and safety glasses have come. Construction drones, in my opinion, is a big innovation, especially for the construction people, where you can monitor large stretches of road or canal lining or remote places very comfortably. So also multi-storied buildings, you can reach in every nook and corner and find out the status of it and understand what is going on at the site. So, and it is coupled with productivity software. So this makes a solid bag. On the material front, as far as the innovations are concerned, many things are coming up. To name few, you can see the screen, translucent wood cooling system with bricks, Martin concrete, biological product furniture, floating piers, even self-healing concrete. Well, in my opinion, self-healing concrete has already come into the market with a big bang, and there are a lot of advantages of it. If you see the basic construction chemicals, which we started using in 1962, construction admixtures, they were developed by Dr. Hirata, Hattori, and Einsberg. And these products were initially not meant for construction industry, they were for leather industry. But we found that SNF and SMF, sulfonated naphthalene formaldehyde and sulfonated melamine formaldehyde, can very well be adopted in the construction industry as superplasticizers, and we started using it. These developments took place, and thereafter, the actual development which has come, especially for the construction industry, in the field of admixture, is done by a young Japanese scientist, Dr. Hirata. He developed a different molecule of PCE. He reacted MPEG with methyl methacrylate or acrylic acid, and he developed a molecule of PCE, which is polycarboxylate ether. And PCE has been changing the entire construction technology in a big, big way. With PCE in hand, now we construction engineers can have a concrete pour of 10 meter at a stretch with congested reinforcement. You can have big raft or mass concrete work of 2 meter thick also on a large scale without any hesitation. There cannot be any cold joints also. We can have free flow concrete, high strength concrete. Many forms have come up. But basically, it is because of PCE. The further development in the PCE technology is a viscoflux technology. Well, I am very proud to be a part of viscoflux technology because this is a green technology. How green? Because basic PCE technology aims at producing a product by heating it up to 160 degrees centigrade in the first phase of reaction, and in the secondary reaction, another 120 degrees centigrade is heated, then cooled, and the process takes around 10 hours. In PCE technology, what you can see on the reactor on the right-hand side, it is only one process. It is almost at the room temperature, no heating, no cooling is required, and the process is complete in 2 hours. So that's a great innovation. Similarly, there are innovations in the other products in the construction side, which is curing compounds. Curing compounds have changed huge amount of water. The water which we are using can be reduced to very large extent. They are of wax base, water base, or aluminized resin base. And once you put a curing compound, then the evaporation control losses, and there can be good protection, and water for the curing can be totally saved. Well, talking about the evaporation control, there is recently a new development. A product has come which is evaporation control agent. Now, this evaporation control agent is a liquid which you can spray immediately after the casting is done on the pavement. So the evaporation controls takes place, and thereafter you can put curing compound and then take care of the pavement things. Well, this is what I have shown in the picture, that in the first slide you can see the evaporation control agent put, and thereafter, after half an hour or so, when the concrete can retain its texture, and you can put do the brooming, texturing, and curing compound. Well, as far as the RCC is concerned, bipolar corrosion inhibitors are one more great product, that the concrete which is embedded, the steel which is embedded in concrete will not rust, and this is a big benefit for the construction. Recently, there are developments in the sealants. White toppings are being done in many parts of India, and for the filling of the joints of these white toppings or tunnel joints or concrete roads, sealants and adhesives with polymer or polysulfide or polyurethane have come in a big way. As far as the construction speed is concerned, there has been innovation that you can have the segment bonded adhesives, what you can see in the lower picture. You can do the precasting at one place, bring the segments at one place at the site, and go ahead with joining of the various pieces and do the post tensioning, and your spans are done with. Similarly, you can do construction over sea or over a river span, or even congested traffic in the city, by having post tensioning method at the top, as what you can see in the picture. This is what I was telling you, that these are the places where segment bonding adhesives have been used, and this is applied on the surface of the segment, and then you put the two segments together. As far as the durability is concerned, yes, carbonation is one process which leads to the disintegration of concrete, and there are carbonation protection coatings which can be used for tunnels, flyovers, and even for the steel structures, there are new protection coatings. Now, this crystalline durability admixture, this, in my opinion, is a game changer, because this product, when you add into the concrete, it can bridge the cracks and the fractures in the concrete even up to 0.5 mm thickness. And this crack bridging process takes like a self-healing, and that is why sometimes it is called as self-healing concrete also. And what you can see on your screen is a laboratory example of how the self-healing takes in around 30 days. Now, coming to the sustainability part of it. See, if you see overall construction industry, 40% of the global energy is consumed by us. We are also responsible for 40% of the waste generation. Not only that, we are producing 50% of the carbon dioxide emission. So we are not very green or very environment friendly institute, this industry, I can say. What we will have to use, that if we want to be sustainable and good industry, we will have to use all the innovations. We will have to use supplementary cementitious materials like fly ash, microsilica, industrial waste. And not only that, once we make a nice concrete mix design out of it, with the help of PCEs, then obviously with better concrete technology, you get durable concrete because there is a longer span, and the longer span will again give you sustainability. So whatever we have talked about the innovations, now if we put it into the field, we will be achieving better and better sustainability. What we have to do is we will have to forget the old technologies of admixtures, that lignosulfonate, SNF, SMF. These were red technologies in my opinion. What is green is polycarboxylate ether and viscoflux technology, which is going to give a lot of benefits. So also, once the structure is done with, we can have some of the new products which have come is foam concrete and albedo paints, which will give you a very sustainable structure. This is what the foam concrete is this. And similarly, for the cool roof, for reflecting heat and keeping the roof cool, these cool roof products are used, and they help to drop the temperature to the tune of 10 degrees centigrade. And this is one good example, in my opinion, of a sustainable construction or a sustainable product. We can definitely replace the conventional plaster by activated carbon or charcoal plus industrial waste or crushed sand, and make plaster out of it. And this has been tried, and people are now coming with it. So this will save a lot of natural resources. There is one more new development which I would like to discuss here, is a geopolymer, wherein you are using fly ash, silica film, sodium silicate, metakaolin, and GGPS on one side. On the activation side, you have alkalis, which are NaOH or KOH. Gravel sand, of course, it is used. There is no cement what is used. Once you make this product, the product is really wonderful. It has got a lot of advantages. It is quite light, and it is resistant to pollution, and it is equally strong as conventional concrete. Recently, there are some examples where underground metro tunnel sections have been done in geopolymer concrete with fiber reinforcement in it. Coming towards the end, recently what I found that Israel has developed some protection coatings which will prevent the spread of corona. That's really very good. And these protection coatings can be used in the factories, public buildings, airports, hospitals, and stores. So this is what we wanted, and this has come. So to close up the thing, what I feel, friends, that the things have changed in the world, and what positive thing Corona has brought is the world has changed, and there is a will to act together. And once we use all these sustainable technologies and sustainable products, whatever I have narrated, we can make sustainable future. So let's leave a legacy of sustainability for the future generations. With that, I would like to close. Thank you, organizers. And now I can take up the questions. Thank you.
Good evening, ladies and gentlemen. Ajit Bhate, and I'm going to try to enjoy this current presentation, which will be presented on behalf of Precast India Infrastructures Private Limited. And I welcome all the ladies and gentlemen watching this presentation, and a special thanks to the CIDC and the steering committee, especially Mr. Prashad Chandru, for allowing us to present a case study on precast concrete buildings in seismic areas. This is a project for one of our clients as Infosys in Pune, which is located in the state of Maharashtra, India. So I will begin with this slide, which is very close to our heart. And our project, this particular project, it is a multi-level car park, which has been selected and has been portrayed on the front page of the bulletin 78 of the FIB and the PCI manual. So it is a sense of great pride, and we really cherish this project and all the execution and all the proceedings of this particular project. So I begin by locating. This is the particular area of the project. It is a multi-level car park. This is a 60-acre campus for our client Infosys, and this is a site layout wherein the most important part of this particular project is that this is the car park. It is a little odd in shape due to the size of the plot. And on the right hand side, you will see that there is a very big and a high voltage substation, electrical substation, GIS substation. So we had the installation process over here was quite critical. So this particular building, which you now see, has totally 10 floors, a basement plus 10 floors. It's about 500,000 square feet, and there are about 1,334 car parks and some 500 scooter parks. Then there are 6 handicap parking areas, 8 tempos, and there are about 115 car parks on each floor, 16 meter span, totally about 3,700 elements. And the key features of this particular project is that it has a beautiful elevation. It has a single entry and a single exit ramp. All the hallmarks of an intelligent parking management system have been incorporated into this. There is a huge refuge area for the fire, sophisticated MEP services, and high-end floor finishes. I'll begin the presentation by showing you some of the finished photographs of the site. This is a view of the external facades. So facade. And you can see that the most important part of this building is that though it is a modular element building, the architect didn't, the concept of the architect and the original creativity, he didn't want it to be standard. He wanted the building to be seen differently from every view. Like if you see, this is a different, the when you look at the building from below, it looks this way. You look at the building from the side, it looks this way. Then when you look at it from the front, it is particularly a different view itself. This is from a little bit of a height, and this is from a little bit of an elevation on looking at the side view. This is the view from the corner of the building. This is another side of the building. This is the rear side of the parking where you can see the refuge floor and all the other areas. These are some of the pictures of the corner of the building. Especially you can note here the details of the joinery, which we will come to in a certain time. So these are some of the photographs again. Now these are these are all non-plastered original surfaces of the concrete, precast concrete elements, which have been just spray painted. So here you can see the 16-meter long double T beams, and this is a column grid of about 9.5 meters. And these are some of the ramps, and these are some of the driveways, the staircases. This is the turnstile area when we come inside the building. This is a photograph which is taken at the night time, when the building also looks a little different when it is lighted. Now I'll begin by the story. Infosys wanted to have a very super and a different kind of a building, and they had asked us to, in addition to the car parking, they wanted the building to look a little bit interesting. So they asked us whether we could do something about it. So we had invited some of our architecture friends from Germany, Greece, India, again from Peru and all, and they had sent in their entries for the facade. So you can see here that some of them had sent it on the Indian sari pattern, some of them had metal louvers, and some of them were, modular patterns which are used in nature. Then some perforations, fins. Some of them had skins on it and all. So all these architects had been given a free hand. They had been given all the data of the project, the layout, floor plans and layouts, and they'd been asked to design a particular facade for the building. So I'll begin by showing you just some concepts. So this is the first entry from Germany. They wanted to have a concept of a sari. You can see here the folds of a sari. So they wanted those folds to be. So these are the different type of concepts. I will not go into detail of these concepts. There were some random glass integrated panels which were proposed by this particular architect. Then these are some of the fixing details. This is another entry which wanted to show some night views of the same building, how it would look. Then this is a entry from the Greek architect. There were some metal louvers and some facades with some different type of arrangements. These are some different vertical members which they wanted to do. Then this is an entry from India, where they wanted to show some of the Indian culture and how it is affecting all the things. So this was, if you see this, they wanted to show as if it should take the shape of a cloth which is put out for drying in the air, and how it would be particularly effective, etc. Then this was another entry from India, which were showing metal louvers and some other things. Then these were some other type of precast triangular panels which they wanted to attach in a honeycomb pattern. Then this was another architect from Germany, the second architect, where they wanted to have some light and different types of panels which were arranged in a very different, untypical manner. And they had some different shapes and sizes. So this was another entry from Peru, a very young architect, a very young and brilliant architect. And you can see here that he wanted to, so there were a number of buildings in the particular campus on which he wanted to, they were having different sizes, shapes and sizes in the 50-acre campus. So he wanted to integrate this particular structure in all of these things. So he wanted to design a cover like a living skin, which is giving rhythm to the facade and creating a fashion of repetitive concrete facades, So this was some of the, he wanted to have some sort of a plantations to give it a green thing. This was ultimately not done because it would have been a problem for the maintenances, but this was how he wanted the original structure to look inside. So ultimately this was the winning entry. This was from the architect Domingo Seminario from Peru. A lovely structure. This was ultimately signed off by the Honorable Sri Narayan Murthy, who is the head of Infosys. And the basic concept was the sustainability through abundant natural light, ventilation, and green filters, etc. And the concept of the architect was that it should resemble the warmth of a woven woolen sweater, which had a virtue of maintaining the architectural view and unharmed air circulation, yet allowing a light, mild sunlight entrainment in the maximum area due to the facades being positioned and designed elegantly. So this is a detail of some of the elements, 3,600 elements. So there were 205 columns and 671 double T's and single T's, pre-stressed beams, non-pre-stressed beams. So this is a combination. This is the typical architectural drawing. These are the two inlet and the outlet ramps. And this is a 16-meter span, and this is a 9-meter span. And most of the building is composite. It is partly cast in situ concrete. And I would like to mention here at that moment that this was only our third year of prefabrication, and looking into all the experience of prefabrication which was absent in India, it was a very tough challenge. It would be very difficult to think of doing such a project now again because of the time and efforts involved. But anyway, the structural design was done in-house team. We had an in-house team led by Professor Spiros Choukantas and Mr. Trifon Tropinsis from Greece, which is designed for seismic loads. And the vehicular loads are 5 kilonewton for the basement and 2.5 kilonewton per square meter for the floors, excluding the basement. I would like to say that this is a structural layout showing all the double T's and showing the various columns and showing the facade elements and connections, etc., etc. I'll go a little bit to detail after this. These are some of the sections through the foundations, typical sections. This is a typical. Not a typical section. I would say it is a section of a corner column. If you note that, you can look at these particular corbels. These are for the facade elements, and these are for the connections of the column and the floor slabs, etc., etc. So there were triple floor height columns, 10-meter high columns, which were providing for 3 floor levels of the column. These are some typical pre-stressed beams, pre-stressed inverted T beams. So these are about 9.5 meter spanned beams. These are 16-meter hollow core, double T slabs over here. Then these are the double T slabs, typical section of the double T slab and how it looks. So the 16 meters, so it was a 640 millimeter deep double T beam, including the top slab, but excluding the screed. The thickness of the top flange was 65 millimeters, and it was totally somewhere around 580 millimeters below this slab. The width of the double T was 3,800 millimeters. It was a risk which we had taken considering the transport, but I think it reduced the number of double T's. And if you see that this is a very untypical section because this is 1.9 meter instead of the typical 1.2 meter double T. There were some single T sections which were used for one particular bay. These are some of the spandrel sections which you can see here. By the way, the building would have looked like this if it was not covered with the facade. These here you can see the columns of the 3 floor columns over here and the connections. And this is the spandrel element which is connected to the column over here. Then there were some typical facade elements. Here you can see the mock-up which we had done for the facade, the connection of the facade and the spandrel. Basically, the connection of the facade and the spandrel is this particular element, which is about, there are somewhere around 1,300 of these elements, and each element is about 7 meter long, and it protrudes out by about 1.3 meters. The weight of each element is close to about 2.5 to 3 tons. And this particular element is designed like a couple on this particular spandrel. And you can see that there is a sleeve over here. So there is a dowel in this particular element, and it is bolted from the other side of the spandrel, and this acts like a couple. And this particular face over here allows it does not allow the spandrel to go. So it's in tension here, and it goes in compression here. And this is the corbel which allows which accounts for the shear forces, so to be taken instead of loading the bolts. So this is a typical connection between a double T and a shear wall. Like this is another connection between a double T and a beam. So these are typical production planning stages in which we have to prepare the drawings and the designs, and we have to generate the unique reference IDs for all the elements, the mold allotments, the production, the tracking and control, this thing. So we have our own in-house ProTrack enterprise resource planning software. So we had a very high demolding time. We had a lot of quality control systems, So here at Precast India, what we did was we always have customer satisfaction, on-time delivery, try for zero defects, and continuous improvement processes. So these we work out a lot of coordination with our suppliers, business partners, etc. And these are the typical quality control systems, like pre-concrete, then this is during concrete, then this is post-concrete, before the setting stage, then at the lifting stage, demolding stage, then at the stacking stage, and after that the finishing stage, and then pre-delivery stage, then the post-delivery transport stage, and the pre-erection and the post-grouting stage. So these are some of the checklists which we normally had, like these are the quality assurance plans, etc. for the concrete, the mix designs, reinforcement, etc. Some in-house material tests performed on the raw materials, then in-house cube strengths and all. This is a very standard process that we have. The client used to monitor all these particular things, tests very critically. Then we had done our load tests for a typical hollow core slab, 16-meter long with the thing. So these are some of the tables showing the loads, the observations and the deflections of the particular element, and so the total deflection and the dead loads and all those other things. Similar tests were made for the double T sections of 16 meters. Then these are some of the results of the double T slabs. Then we have we usually do some random ultrasonic pulse velocity tests on all our elements before sending them on the site, and some of this calibration certificates for all the various batching plants and all the other machines and all. In this particular process, the stacking would have been a very critical process. So because of the long span and the geometry of the elements, the lifting systems were designed in-house. So we had a special fixture for lifting all the facades and then stacking them in particular thing. Transportation on site was a definite challenge, and we had to make a special jig. And the weight was not too much, but it was occupying a lot of space. So we had to modify our trailers specifically for doing all these particular structures. I mean, we could transport about 8 facade elements during one trip, and then all the attachments over here were removable, and installation speed was improved due to the proper planning of all these things. Another important thing is during the installation of the facades, you can see all these facades are installed here, but because of this refuge floor, which is projecting out by nearly 3.5 meters. So at that time, we had to make a specific arrangement, because all these other facades are just lowered down from the crane and then fixed on the spandrel or wherever. But here it was 3 meters away, so we had to prepare a specific beam, and we had to have a counterweight on this particular side. And this is the facade element. If you see over here, this facade element was then shifted from this particular this thing. There was a gear put over here, and then it was moved inside towards this. It was a innovative assembly. All these mechanisms were specifically created by us in our own house. These are some of the connections, like column to column connection, spandrel to column connection, facade to spandrel connection, and facade to facade connections. So as I said, the shear is taken by the corbels and the monolithic spandrels, and the interlocking of each facade element with locking actions against the overturning of an individual element was around 100 tons, so 8 tons each. So here you can see the connection of a column and a column to column connection. It's a typical column to column connection. This is 3-floor column, and then this again is another 3-floor column. So over here we used to have sleeves. So these are typical sleeves which were there in the top column, and there were dowels coming from this particular column. And this is a typical, very typical column to column connection. Then there were columns with corbels for resting the facades. So you can, over here you can see that these are the corbels for the facade, and these are the corbels for the spandrel. So these are some plates which we had kept for inside the column, in which the spandrel was later on lowered. These are some of the corner columns. This is a special. It's a nice shot where you can see that the facades on one side are installed, and this is the other side. So if you could just visualize the column which we had shown, it had corbels on both these faces, and this is a particular jig which we had made, and we used to lift the facade and then fix it on both these corbels, and then we used to bolt it. So this is a typical corner connection for different things. So these are connections of the, the column and the corbels for resting the facades. So over here you can see that this is a particular spandrel, and in this particular picture you will be able to see that this is the column, this is a knife plate over here, and then this particular spandrel could slide inside, and then the dowels from this spandrel would go inside the corbel of this particular column, and and then the facade would come over here, and this is one facade which would be bolted on the spandrel, and this is a typical side view of the spandrel, where these are the columns, these are the dowels which go inside the column corbel, and these are the dowels left from the spandrel which go into the screed along with the which is above the structural screed, which is above the double T. So this is again the connections which was there. So over here you can see that this is the column, this is the knife plate which is there, and these are the dowels which go inside this corbel. Like this detail shows everything in detail, including the bolts for the facades also. So this is a view of the building when it was half completed, sort of. So this is the corner column, and these are the individual spandrel elements, and these are the columns which are precasted. The internal shear walls were casted in situ. So here you can see that the facade to spandrel connection. This is the facade element, and this is the spandrel. So here you can see that there is a bolt. So this particular bolt, and this is the notch for the corbel. So if you go back to the mock-up, this is the corbel, and this is the particular. So this particular element is bolted from the other side and then grouted, and then the next element comes here. So here, what you can imagine is the number of the accuracy. If you go back to this particular picture, then you will notice that accuracy has played a very important part, because these are the two sleeves which keep. There is on this corbel, one element sits from this particular side, and from this particular side another element sits. So basically there are two sleeves over here, and the sleeves are 40 mm diameter, and the bolts are 16 millimeters. So you can imagine that if this is not correct, looking at the tolerances of the entire building, that means the tolerance is kept in the columns and the tolerance is kept in this particular element, and then at last the facade would come in. So it was a very tough task, but our engineers had done a very nice job, and that's why we could see that there was no mismatches. Another unique feature is that this is a spandrel which is fixed on this. This is a facade element which is fixed on the spandrel. This other facade element is fixed on the spandrel on the top. So this is the spandrel element of the floor on which we are standing, for example, and this is the next floor. And as I said, the double T sits on this. And now this particular facade element, if you see, is totally in the air. So what happens is that there is a dowel, a sleeve in this particular element, in this particular facade element. There is a dowel for this element. So this dowel comes over here. So it is fixed here. And if you can see over here, there are two bolts casted monolithically with this particular facade element, which are fixed internally from here. And there is an insert plate in this particular beam. There is a bracket over here, a steel bracket, and then this is pulled inside from here. And this facade from the top is pressing it on the from the top, so that it does not allow for the this particular facade to overturn or something. So this was the degree to which the detailing was done. It was a super detail by Professor Stiras and his colleague Mrs. And this is a 3D view which shows the connections of two facades, how it is kept. And this is the corbels, and these are the various bolts which are there. So then we had a overall accuracy up to 15 millimeters. There was no adjustments and its location, etc. It was a very super connection and all. So there's some special types of concrete which we used. There were a lot of safety measures for this project, toolbox talks, and then method statements, checklists to be maintained, equipment installation carried out, all the color codes for the various installations thrice after 3 months, daily observation tools for safety, etc. And everything was followed quite mandatorily, and there was a very strict monitoring on the site. There were 0 accidents on the site. And these are some of the photographs of the building which was executed. So this is a 50-ton tower crane, Liebherr 50-ton tower crane being erected on the site. And this is the plot, like we said. This is there is a substation very close by over here. So what we had done was we had constructed this particular part first, and then these two parts were, this was the part 1 which was completed. Then we had checked everything for the seismic checks during installation, whether it could stand alone, etc. And then these two particular towers. So this is a tower crane which is moving on rails. So there was a very tight side margin. I'll show you in some other photograph. So if you can see, this is the electrical substation. There are no space around the site. This is where the tower crane is moving. So this tower crane is going on rails this way, and it is partly cast in situ shear walls for the lift course. And all these columns are precasted, and these are the 16-meter double T's which are there. These are the precast pre-stressed beams, etc. It was a very tight site, and yeah, we had used everything for the final finishes, boom pumps, etc. Everything. This is the second part of the building which was completed. And this is the part B, which is when the crane was shifted outside the building. So here you can see that these are the two parts which are first brought up. Then this crane used to come has to come out, and then the front part was done, the C part of the building. This was during the execution of the building externally. Then this was again when part here you can very clearly see that this C-shaped portion of the building is completed, and this particular crane will be shifted outside here on the rails. It will be fixed over there, and then this particular part will be completed, I think, which we can see in the next picture. These are again some of the activities related to the typical floor finishes, etc. So these are some of the typical shear walls, cast in situ shear walls, 18-meter long, 4-meter high. Then this is again like what we said, that this was the 3 parts. Now the crane will be moving outside from here. Then this particular part will be completed, and then the facade will be installed. So like I said, this is the last part of the building. So this 1, 2, 3 parts were first done. Then this central part was done. The crane was taken out from here, and then this particular area was installed. So it was very tight from all sides. And these are some other excavation for the site development activities, etc., other things. These are some of the photographs. The thing that this is, like I said, the crane being taken outside, and then the last part of the building being installed now. These are some photographs during installation of the columns, etc. You can very clearly see the knife plates for the column, and the corbels for spandrel elements, etc. So the building would have typically looked this way, but after the building is completed, it is totally different. These some of the facades have been started to be fitted here. So this is again, we had a 30-meter tower crane. So at one time we had about 5 cranes on this particular project, and so this is the final stage of completion of the facade erection. These are from different sides, dismantling of the crane, and then I would like to mention some of the awards which we had received for this particular project. Like this was a particular award for the this is a very important award. Like the Indian Concrete Institute had conferred the Outstanding Concrete Award 2016. Then these are some other Construction Week India awards. Then some of these local awards for the Builders Association in India, etc. This project was also uh, this was also presented by us in Madrid for the international conferences and on sustainability, etc. All in all, this was a very super project where I won't go into the details of all these other things which show that embodied masses, energies, etc. are better. So it was from the sustainability point of view. But all in all, what we found was that this is like, this is the conceived structure and this is the final structure. So without any particular changes, we finally managed to finish this particular project. It is very close to our heart, very challenging project, design-wise challenging, production-wise very challenging, transportation-wise very challenging, but it's a feather in our cap. And like we said, ultimately it featured on the cover page of the Federation International de Beton. And ultimately, like I said, we do everything for the passion of concrete, and prefabrication is our soul. So I stop my presentation over here. Thanks from Ajit Bhate and all my fantastic team of engineers who has worked very hard for this particular project. And yeah, I hope it was interesting. Thank you. Thank you very much.
Hello and welcome. Hello and welcome. I am Sanjeev Sharma and I represent Melior Structure Solutions. We are specialized in precast structural design of buildings. Today I'm going to cover structural design of precast high-rise commercial building as a case study. The project is a commercial building with 4 basements, ground plus 24 stories above ground. As you can see in the plan, it is approximately 200 meters long, 34 meters wide, and 110 meters tall above ground. It is designed as full precast building above foundation, though later suited to be constructed with cast in situ columns and walls above 6th floor due to construction constraints. The screen shows the list of the design codes that has been followed. It covers the Indian codes for the loading, for the concrete design, for the seismic loading, the code for the tall building, and where information in Indian codes is insufficient or unavailable, following international codes are referred: ACA 318, which is for the concrete structure, and PCI design handbook. So the concrete strengths for the structural elements is listed here. Typically columns have higher strengths at the lower levels and it's reduced at the upper levels. Beams which are pre-stressed has 50 MPa, non-pre-stressed has 40 MPa. Walls also, like columns, varies in strength from 40 to 70 MPa. All pre-stressed elements are minimum 50 MPa. Reinforcement FY 500 MPa is a grade that has been used. So here's a list of the live loads that are considered for the design, and these are as per IS 875 and also as per the utility of the area. So the earthquake load is applied as per Indian Code IS 1893, seismic zone 2. These are the factors that has been listed. Wind loads were applied as per the wind tunnel test outputs that were carried out by a specialized agency specific to the structure, this structure. So this slide shows the typical layout. As you can see, the upper plan shows a typical floor plan, and being fairly long, 200 meters, it has been divided into two towers separated by an expansion joint. So for the analysis purpose, two separate analyses were done for each of the tower. We can see on the lower half the left part of the building, and the arrangement is typically a hollow core slab as a floor system, beams and in the perimeter and in one direction in the middle supporting these hollow core slabs, columns supporting the beams, walls, and the central area with which is basically the core slab, the central core and lobby, lift lobby, staircases, etc. The structural system for the gravity loads consists of hollow core slabs and cast in situ structural topping. The hollow core slabs are pre-tension slabs, so they can go long spans with lesser thickness. The precast beams and walls that support the floor slabs are provided. We're going to explain them in more detail in the coming slides. The precast concrete columns, they support the beams, and columns and walls together, they transfer the gravity loads to the foundation. So together these four elements constitute the gravity load resistance. The lateral loads are mainly resisted by the walls and to some extent by the moment resisting frames. The structural concrete topping is provided to act as diaphragm in order to transfer the lateral loads within the horizontal plane to the shear walls and moment resisting frames. The design methodology, if we start with the floors, as we can see here, the precast hollow core slabs spanning one way are supported on the partially precast pre-tension beams forming the floor system. The hollow core slabs are voided slabs and are typically 1.2 meter wide. They have a shear key profile at the edges, and they are laid next to each other as a one-way spanning planks, and there is a reinforced cast in situ structural topping over the hollow core slabs that act as composite with the hollow core slab in resisting the gravity loads, and that topping also acts as diaphragm connecting the shear walls, thus enabling resistance against lateral forces from wind and earthquake. Coming to the beams, they are partially precast with top 150 mm left without casting but with projecting stirrups. Now, after erection of hollow core slabs on these beams, the top reinforcement is placed at site in the top part. Reinforcement is continuous over support and gets integrated with the projecting column reinforcement, thus forming the moment resisting frame. So these frames are in one direction, as you can see in the image. So the connection is stitched at site, cast in situ, but once the connection is done and the top part of the beam is cast, then the full depth of the beam is activated and they act as a one-way moment frames. So next coming to the vertical elements, the columns and shear walls are collecting the vertical loads from the beams at each floor and transfer them to the foundation. The columns, mainly they collect the gravity load, and the shear walls also provide lateral stability against wind and seismic forces. The connection details on the right are blown up and for clarity, and the arrows show where this detail is applicable to the structure at site. Similarly, the wall slab connection is blown up to show how the wall-to-wall connection is made and where it is applicable at the site. As far as the foundation and retaining walls are concerned, they are cast in situ. The foundation system is isolated foundations under the columns and mat foundations under the shear wall and stair walls, lift core walls. The retaining wall has a strip foundation below it. All the foundations are connected with a stitch slab at their top, forming a watertight base. This stitch slab is important because it's a basement structure and there is chances of water seepage happening due to floods or due to rainwater seepage. And to avoid that penetrating into the basement, another stitch slab at the top is provided with waterproofing. So we discussed the gravity loading, we discussed the lateral loading, and this is a summary of it basically, that the sizes that we typically arrived for this building. So since the hollow core slabs are spanning around 10 meters, and for the live loading of 5 kilonewton and 10 kilonewton in some areas due to server, 250 hollow core is provided for the car park and office areas, and 300 hollow core thickness for the machine room areas is provided. The structural topping is mostly 85 mm in all the areas, because for longer spans there is a camber also in the slabs, and to cover that and to embed the services, MEP services, 85 mm of the thickness is recommended. In some areas where heavy loading is there, we have increased the topping and provided up to 185 mm. Precast beams are typically 1400 wide, including the nib or the ledge for supporting the hollow core slabs, and they are 600 deep in total. So the precast part is 450 mm and 150 mm part is done at site with cast in situ concrete after placing the top reinforcement. The columns are typically 1.4 meter by 1.4 meter up to podium level, which is ground floor. Then from ground above up to 15th floor, they're reduced in size from 1.2 to 1.2 meter, and above 15th floor, they are 1 meter by 1 meter. And also the grade of the columns are reduced as we go up in these levels. The lateral loads from wind and earthquake are resisted primarily by shear walls in both directions and nominally by moment resisting frames. Structural concrete topping is provided over precast floor slabs to act as diaphragm in order to transfer the lateral loads within the horizontal plane to the shear wall. The RCC walls are 250 thick and 200 thick up to level 3, and 200 thick from level 3 onwards. There are some outriggers provided on the perimeter for stability. There are 350 thick. The very important part of precast design and construction is connections, because each element is produced individually in the plant, is shipped to site, and at the final location they are assembled to give a monolithic equivalent effect. So precast hollow core slabs at the edges have shear keys that distribute the local loads over a larger area, similar to monolithic construction. The reinforced structural topping over the slabs further assists in the same. The U-bars connecting the topping and shear key assist in composite action and avoid diaphragm buckling. So it's important to have a shear key, and the hollow core shape comes along with it. And if you have a U-bar within the shear key with the topping, so that bonds the topping and increases the bonding between the topping and the hollow core, that assists in composite action as well as the Next connection is hollow core slab to beam connection. This is a very simple connection. The hollow core simply sits on the beam ledge on a leveled ledge, and the cast in situ topping is done over it after putting some reinforcement in it. The reinforcement of the topping penetrates into the beam, and sometimes we also place one rebar every joint of the hollow core slab, which comes at 1.2 meter, to avoid progressive collapse of the hollow core slab in case there is a loss of support. Two types of beams are shown there, one which is perpendicular to the hollow core span carrying the hollow core, and the other is parallel to the hollow core and therefore doesn't require a ledge to support the hollow core. Next connection is a beam to column connection, also a very important connection, and this connection is designed as a moment resistant connection. So the load bearing beams are partially precast and they rest over the column corbels at ends. The top reinforcement of the beam is continuous over the column and thus resisting negative moment formed at the junction. You can note that the beam bottom reinforcement also is connected into the column, forming a unidirectional moment resisting frame. In each direction. So we also have a frame in the other direction, which we saw in the previous slide, and that is basically not carrying the hollow core load, but is participating in stability to some extent. The other connection is a hollow core slab to wall connection. The hollow core slabs rest on the walls with minimum bearing as per code, which is typically 75 mm. In special cases, it can be reduced though. The rebar projecting from the wall is bent into the cast in situ topping over the column-to-column connection is proposed using reinforcement and proprietary slide sleeve connectors, such as from Dextra for this specific project. The high-strength non-shrink grout is filled in the gap that ranges from 20 to 25 mm. The connection is capable of compression, tension, and bending moment. Actually, this connection is equivalent to Type 2 coupler. This is a very well recognized connection. Now we come to wall-to-wall connections. So the wall-to-wall has vertical joint and a horizontal joint. The vertical joint wall-to-wall connection is proposed using proprietary wire loops, as you can see in the image, 3D image shown on the right bottom side. So these walls, they are very easy to make these connections in these walls. The wire loops are flexible, they are like strands, so they pop out during erection, and the gap rebar is placed in this junction and the grout is poured to make the connection. As far as the analysis part of this connection is concerned, the walls are modeled with gaps in case of a wire loop connection. So the horizontal shear transfer is limited, and hence it doesn't give exactly as a continuous wall behavior. So the wall gets broken here, and that is reflected in the model. So the shear key gets formed at the vertical edge that additionally assists shear transfer between the two walls panels. Some shear walls at periphery are connected in this particular project with a stitch connection, as you can see in the left to bottom detail. Then comes wall-to-wall vertical joint. They are similar to knee tabs as already explained. And precast wall-to-wall horizontal joint is equally very, very important connection, and they are very similar to how the column-to-column connection is made using either reinforcement and dowel tubes or the reinforcement and proprietary splice sleeve connectors, such as from Dextra. The grout is filled in the gap, as you can see, it's filled from the bottom and it comes out from the top. The building structure analysis 3D model is made in ETABS software with all geometry and cross sections of elements assigned as per the drawings. The loads are assigned based on the functionality of the space as listed before, and linear elastic three-dimensional analysis is carried out for the output forces. The response spectrum analysis is carried out for the seismic loads. The design of beams, columns, and walls are done from the ETABS, whereas the hollow core slab is done in another software, which is Concise software, or manually using. So after we get the results, the design drawings are prepared with all the details as we do in cast in situ structure. And additional thing required for precast is a fabrication shop drawing, which shows all the dimensions of each individual element, all the accessories embedded inside it, all the connection requirements for each panel. So for each element, three sheets are required. One showing the and accessories. The second sheet shows the reinforcement. The third sheet shows the MEP details. Finally, this is how the stage-wise the building was constructed at site, and the building is already completed, possibly ready to be occupied soon. Thank you for your time. Thank you very much.
Good morning and welcome you all. I thank our Society for Engineered Structures Society of India for giving me this opportunity, and also CIDC for conducting this conference and giving us this opportunity. Today I'll be sharing my topic of precast construction industry policy reforms and contracts. So we all know precast concrete industry is growing at a very impressive pace, and but still it requires some boosters like policy reforms and changes in the contract conditions to help precast contractors execute more successfully actually. So with this background, I would like to say my overview of the topic is precast construction in India, and then projects of different categories for which we need to talk about this policy reforms and contract conditions changes. So we all know precast construction in India, the technology has taken leaps actually, because though the precast construction started about 50 years back in India, but it couldn't take off because of various limitations of the policies of the government and also availability of the equipment readily and all that. But we all know precast construction helps facilitate this faster and quality assured construction, and the volumes whenever which is happening in our country now, large scale housing constructions or large scale building constructions will help, this technology will help achieve the delivery in time with the quality required and with a fixed cost. And technology innovations, like multiple technologies are available in precast, we all know. And in India, we are able to cope up with the latest developments happening, whether it is modular precast or total precast, or it is upgrade technology and normal panels construction. All these technologies are available, and we have equipment for erection also, for heights, including the tower cranes and the reach of the booms. They're all available now, and we all know the engineering and architecture is also gearing up to plan for these precast technologies with columns, light wall panels or structural wall panels, double T's, hollow core, inverted T-beams, spandrels, rectangular beams, stairs, and all that. So these are all the precast elements we all know. And the benefits of going for precast basically is the buildability and factory production with the proven design methodology, planned and speedy construction program for which we have very good IT support, economy, eco-friendly with less wastage and no pollution, sound pollution and air pollution, health and safety of the workers and inherent fire protection properties like cover and quality of the concrete and durability. Mainly, major advantage is the durability and efficient reinforcement with the large span and air tightness because of the lesser porosity and lesser permeability in the concrete, because concrete being produced in a controlled environment. So the cycle starting with the planning, design team setup, and preliminary health and safety statements and precast health and safety, design risk assessments, and then access and cranes availability and access of vehicles, trailers, and then the crane movement and crane operating convenience, and then design statement, design brief, and the preliminary drawings like general arrangement, and then document control, approval process, and drawing sign-off procedure, project program for the precast starting from casting, curing, transportation, erection, and alignment, and the final acceptance tests. And for every all these activities, method statements being prepared, and site preparation by the main contractor for foundations and stores, and stacking and delivery and acceptance of the materials at the site. And for all this, we have to have the quality documentation, installation and approval and sign off finally. So these are all the typical process, and we all know about this dry method, dry joints and wet joints, and then parking garages, and advantages we all know: high quality control, speedy construction, reduction in formwork and scaffolding, and any shape and any finish can be achieved with this, and durability is the major and aesthetic appearance. So these are all some of the drawings, which shop drawings, which we have to make with all the details of the stripping, stacking, transportation, and erection, slinging, all this what I'm showing here. And so this is the brief background about precast and where it stands in our country today. So now what are the policy reforms we require to further boost this precast technology in construction? This is basically the discipline from within the industry, like quality delivery and keeping up the timelines is very important. Otherwise, any one or two contractors failing also, it is affecting the acceptance by the clients and corporates. So we all industry people have to be abiding by this discipline about the standards and procedures. Next is the monitoring and regulation is required definitely, like our society, PSI, Pre-Engineered Structure Society, can offer to do this monitoring and regulation, and design methodologies, uniform design standards, manual, which can lead to formulation of the codal provisions for future, and buildability score. I feel that the Urban Development Ministry, we have to work with to introduce the buildability score so that the precasters will get the advantage in getting the permissions because of its buildability with least inconvenience to the neighbors. That's very important. So this is already prevalent in other countries like Singapore, BCA and all. So we have to also bring in this concept. And next is the insurance policy. The insurer is not talking about different premium for precast construction where it is less risk involved during the construction because of more engineering, and conventional construction where it is riskier, and we are seeing so many accidents happening, reported itself or so many, there will be so many unreported accidents. And so we must pursue with the insurance companies and the government to get the insurance policy. That means to penalize the people who have more risk. So there should be proper risk assessment for the insurance policy. Next is the GST taxation. There should be incentive for the completely organized industry like precast, because there is no material or work that can go unaccounted. So it requires definite incentive or subsidy to encourage this nascent and upcoming industry, which will bring in more organized taxation actually. So GST, we should request the government to give incentive in the GST. And the next important thing is Bureau of Indian Standards to come up with more rational partial safety factors. Like we have this dead load 1.5, live load 1.5, other wind and earthquake 1.5. But if we can introduce the modeling of the uncertainty using fuzzy logic, we can arrive at a more realistic and logical factor for precast, because in precast we have lesser tolerances and more fixed dead loads, like self-weight of the structure is very much fixed because of the lesser tolerance. So these are all the important policy reforms I recommend and request every stakeholder to participate in achieving these policies. And then in procurement contracts, the design build contracts particularly, where it can be a lump sum contract or item rate contract or a yardstick contract, we should make the client to make it technology neutral, because the precast technology is patented by different companies and each one have their strength. So you define your battery line of the building and the rest let it be decided by the consultant and precaster to implement this technology neutral. Next is eligibility criteria. We cannot apply the same pre-qualification requirements for precast as well as conventional. So it requires involvement of the industry to come up with recommendations for more rational eligibility criteria. Next is the LD clause. It is hardly negligible in my opinion in the present condition because of the lobby of the conventional contractors. And we all know that the construction contracts run into 5 years period average. I have some contracts going at 10 years also, because it's very difficult to control this timeline. So unless we have stringent LD and termination clause and risk and cost clauses implemented, it is very difficult to really attract this technology implementation. Next is the incentive for timely or early completion. Also should be there in the contract. Then people will move out to this precast technology. Next is the advance cash flow requirement will be different for precast because it's the faster work and we have to cast all the elements before erection, and it will all happen in a short span of 3 months. So we have to think of drafting mobilization advance and material advance clauses differently for this precast. And finally, the terms of payment and yardstick turnaround time, because it's very fast, unlike conventional method where you have 1 month cycle time. In precast, we have 2 days, 3 days kind of cycle time. So for that cycle time, the billing cycle also has to be faster and or advances to be paid. So we have to relook at the estimation of the yardstick for the contracts and terms of payment. So with this few words in the given time, I could cover as much as possible. And thank you very much. And you can always connect with me on my mail or number or my Facebook page or LinkedIn page. And thanks for giving me this opportunity. You can shoot out your questions to these numbers. So thank you. Bye. Good morning.
Dear participants, I am so happy to announce that CSIR and CBRI, they have gone in for a very novel initiative, and this is to nurture the emerging technologies. They have set up a construction technology demonstration park at CSIR CBRI Roorkee. The park is a construction technology fusion ranging from vernacular to blue sky, 3D printing, emerging precast, prefab technologies, and the technologies are not only demonstrated there, but also are evaluated for different functional tests. That is water tightness, acoustics, thermal comfort, and axial and lateral loads, etc. The emerging technologies being evaluated are precast hybrid buildings, confined masonry, cold form steel, dry construction, bamboo housing systems, 3S precast building systems, prefab steel housing building, and a stay-in-place formwork system. The benefits derived from the park are that they bring all the emerging construction technologies at one place. It creates a technical data bank of various existing alternate materials and construction technologies which are time-tested and proven and can be really used in the field based on the geoclimatic conditions. It also helps in development of test protocols for functionality performance evaluations of buildings using emerging technologies. Do visit and have a look at it, and also the appeal to the young students is who are going to be now professionals in tomorrow. They should basically be part of this particular visit, and they must spend time and learn new techniques. Thank you very much, and I once again repeat, you are all invited. Thank you.
Central Building Research Institute, also known as CSIR-CBRI, is a constituent establishment under the umbrella of the Council of Scientific and Industrial Research, CSIR. It has been tasked to generate, cultivate, and promote building science and technology in service of the country. The National Mission Housing for All strives to meet the housing demands of the people of India by the year 2022. The conventional methods of building construction are unable to meet the targeted housing demand. This requires new and emerging building technologies that are cost-effective, faster to construct, disaster resilient, environment friendly, aesthetically pleasing, comfortable to live in, sustainable, and durable. These technologies will set a direction that our future cities would follow.
The economy of a country is proportional to the infrastructural development. The country looks for a 5 trillion economy, and it is very important we resort to new ways and new technologies in the construction sector, such that construction technology plays its vital role in the economic development of the country. Towards this aim, the team from CSIR-CBRI, ably guided by Dr. Ajay Chaurasia, has led this attempt on creating a technology demonstration park for construction technologies. Construction technologies now have moved away from the conventional means where the time of the project takes a very long duration. We need to make it as quick as possible, as economical as possible, hazard resistant, as well as with a high comfort level. With all these parameters in our mind, we have created 8 to 9 demonstration structure as a pure experimental attempt, which is on a high TRL level, technology readiness level.
The CSIR Central Building Research Institute, Roorkee, India, has developed common platform for full-scale demonstration and performance evaluation of promising building technologies as Construction Technology Demonstration Park. Demonstrated here is a fusion of construction technologies that offers a wide choice of options to industry, academia, and researchers for mass housing projects under different sets of geoclimatic conditions. The park currently showcases 2-storied houses having a uniform layout with a total covered area of 1100 square feet for each building. The bouquet of technologies demonstrated here covers a wide range of partially precast building components, use of locally available materials in a scientific manner, fully precast industrialized buildings, dry construction using steel framework with commercially available wall cladding materials, structural use of bamboo in buildings, and integration of energy efficient green building systems for both hot and cold climatic areas. The approach adopted introduces standardization in housing layouts through modular coordination, efficient space utilization, climate responsiveness, energy efficiency, disaster resilience, and cost effectiveness. These technologies will be subjected to rigorous evaluations of water tightness under cloud burst simulation, to acoustics performance, thermal comfort, indoor or outdoor air quality monitoring, performance under axial or lateral loads, fire resistance, and many such tests that are needed for safety, durability, and comfort of the users. Emerging building technologies, partially precast hybrid construction. In this demo house, partial prefabrication techniques have been demonstrated that are more amenable to construction system in India. The walls have been constructed using specially developed concrete blocks that have large irregular stones inside. Brick masonry in rat trap bond saves 25% bricks and gives thermally efficient walling system. Precast like the RC plank and joist system, precast channel system, brick panel system, L panel system for sloping roofs, precast stair units, precast door and window lintel cum sunshades have been used here. The house is safe against earthquakes even in zone 4 and 5, cost effective, and makers use of locally available construction material and skills. Bamboo housing systems. Bamboo has very good mechanical properties and can be used as a good building material in the construction of houses. For durability, these bamboos have been chemically treated against insects, termites, fungi, and rot. The bamboo structure has been specially designed for required structural strength as columns, beams, trusses, staircases, and safety against earthquakes and winds. The bamboo wall panels have been protected against rains by ferro-cement plaster on all exposed walls. Net Zero Energy Building. This is a net zero energy house. Industrial wastes like fly ash has been used in the bricks that do not require coal for burning in kilns. Also, biobricks using desert sand having good engineering properties are utilized for wall construction. Bamboo is used to replace steel in tie columns of confined masonry. It also demonstrates several innovative passive techniques for natural ventilation and to keep the house warm in winters and cool in summers. Natural indoor lighting and solar energy injection in the main power supply is likely to offset all but the little power that the house takes from the electric supply system, making it a net zero energy house. Here, cold formed steel wall panel framing technology has been demonstrated. Cold formed steel wall panels have fiber cement boards and gypsum boards on both the sides. Rock wool is sandwiched between the gaps for insulation. These panels are the main axial load-bearing members in this system of construction. This system is environment-friendly and has high strength to weight ratio. Due to faster construction, easy transportation and good thermal comfort, this system can also be adopted in the earthquake-prone, cold hilly areas. Dry construction. This is a dry construction technology where no water is used during construction at site. The main load-carrying frame of the building is made of hollow steel sections with strong monolithic beam column joints for improved performance. Bolted steel joints make the work at site easier and faster. Various types wall panels available in the market can be used with this steel framework. By proper planning, a 2-story house can be constructed within about a week. 3S Industrial Precast Building Systems. Messrs. B.G. Shirke, Construction Technology Private Limited, Pune, has demonstrated here an industrialized precast building system. Complete multi-storied buildings are pre-designed and industry-produced using high-quality RCC building components like columns, beams, walling, and roofing components, stair flights, and walling blocks or components. The structural integrity of the system has been evaluated by CSIR CBRI on various parameters. Everest Steel Building. This is another pre-engineered house demonstrated by Messrs. Everest Industries. Here, the designers have used a hollow steel section frame to carry main structural and imposed loads. The frame is nut and bolt jointed, minimizing on-site assembly work. Their proprietary wall panels consist of an aerated cement concrete core sandwiched between 2 cement boards. This too is a dry and fast construction system. Several walling panels and finishing boards have been displayed here. Innovative building materials, components, and systems like sea brick or cement fly ash bricks, concrete masonry blocks, desert sand bricks, construction and demolition waste bricks and blocks, rat trap bond masonry, earthquake resistant construction techniques, foldable shelters for instant relief and rehabilitation of disaster affected people, solid waste disposal systems for rural and semi-urban localities, several passive systems of thermal comfort, lighting, and household cooking have also been integrated with the demonstrated houses. These buildings shall be scientifically evaluated for their functionality performance under water tightness, heavy rains, natural hazards like earthquakes, cyclones, floods, fire, indoor and outdoor air quality, and also comfort level in hot, dry, and humid geoclimatic conditions using IoT-based system. In addition, the buildings are provided with wind and solar hybrid WISH energy generation systems by CSIR NAL Bangalore.
This construction technology demonstration park is a stepping platform and provides several benefits for the growth of construction industry in India. To name a few, it brings all the emerging construction technologies on a common platform for demonstration, awareness, and evaluation. It creates a technical data bank of various existing alternate materials and construction technologies which are time-tested and proven and can be deployed in the field based on geoclimatic condition. It also helps in development of test protocol for functionality, performance evaluation, and many more. In the end, our aim is to meet the aspiration of the people of India from construction industry. It is expected that more and more technologies will be added as and when developed and verified in near future.
Construction cost, construction speed, capital investment, and public acceptance are important parameters that decide the success of a housing system. This demonstration park will help users, designers, and builders to select the most appropriate building technology for their geoclimatic conditions. Through meticulously designed, researched, and evaluated building systems, materials, and components by the scientists of the CSIR CBRI, India is edging closer towards more scientific and technologically feasible solutions towards fulfillment of the country's dream of housing for all by 2022.
Hello ladies and gentlemen. As we all know, the world is facing a horrid time due to COVID-19, and the construction industry also has been adversely affected by this pandemic. There are many challenges that consulting firms are facing, like staff not attending office regularly, movement of people to project sites, deployment of staff on projects, day-to-day monitoring of projects, etc. MSV has visualized the challenges related to COVID, and we have created SOPs to work in these tough times. Barring a few cases, we have been successful in fighting this deadly disease and have continued to provide uninterrupted consultancy services. We reorganized and reoriented the company so that everyone remains in touch with all the team members at all times, electronically and digitally. Our head office staff was provided with laptops, internet access, Microsoft Teams and WebEx to conduct virtual meetings, exchange files and documents, and stay connected with the team from their respective homes. COVID-19 could not dampen our spirits, as more than 90% of our team members continue to stay at more than 100 plus project sites of MSV. Our HR department played a crucial role and regained the pace of work in a short time. Our head office and HR stayed in constant touch with our esteemed clients and provided feedback and monthly reports regularly. Innovative approach, good leadership, and high motivation paid off well. During COVID times, MSV submitted bids on more than 200 projects, and we won more than 30 projects, adding to 150 crores in consulting fee from March 20 to October 2020. Which is a great achievement. MSV took a landmark decision to curtail company profits and release additional financial resources to provide full salaries to all our 1400 plus staff and employees during these challenging times, to ensure that everybody has a smile on his face. I would now like to take this opportunity to talk about some of the irrigation and agriculture projects undertaken by MSV Inc. We have worked on irrigation projects world over, and most of our projects have been done in India, Africa and US. Some of the projects undertaken by the chairman of MSV, Mr. Malik, in United States are Squamish Canal modifications for the Department of Ecology in the state of Washington, USA. We also did a project for Up Lake Basin canal systems in Washington state. We also did modifications and extension of existing Wenatchee canal systems in the state of Washington. We have recently finished a project in Africa for design and construction supervision of irrigation schemes for a World Bank funded project in Ghana. We also completed 2 projects in India which were funded by the World Bank. The first one was the Andhra Pradesh community based tank management project and the Odisha community tank management project. I'll be talking about these projects in detail. We also provided consultancy services for construction supervision and quality assurance for reconditioning and rehabilitation of distributaries and miners in Bhatinda and Faridkot in Punjab. We have provided supervision and quality control services for Patiala Canal Division also. We did the Andhra Pradesh community-based tank management project and we provided third-party services. As per a World Bank study, the tank irrigation system in Andhra Pradesh is centuries old. Tank system structures were mostly constructed to support the basic human needs. Between 1999 and 2006, agriculture grew at 2.5% per year, with almost all growth coming from livestock and fishery subsectors. However, the crop subsector, which accounted for about 60% of the state's domestic production from agriculture, stagnated. Consecutive droughts and inadequate investments in irrigation were the key factors for poor agriculture performance. Farmers who did not have access to canal irrigation relied on surface irrigation from tanks for cultivation in addition to rainfall during the monsoon season. The state of Andhra Pradesh had the largest number of tanks, approximately 74,000, and the largest area irrigated by tanks in India. However, from 1999 to 2005, the state saw a steady decline in tank-based irrigation. From 1 million hectares, it was reduced to 0.5 million hectares due to lack of maintenance and increase in use of groundwater for irrigation. Most tanks were performing well below their capacity, and the percentage of actual area irrigated to potential created varied between 35 to 55% depending upon rainfall. The components and objectives of the project were institutional strengthening, to enable community-based institutions, water user association and fishing cooperative societies, farmers' interests, assume greater responsibility for tank management and for improvement of tank-based agriculture livelihoods. Second was minor irrigation systems improvement to enhance the efficiency of water use in tank areas selected under the project. Activities to be undertaken fall under 2 subcomponents: tank system improvements, and objectives of the subcomponents were to improve the physical and operational performance of selected tank systems, then secure the safety of the tank structures, improve on farm water management and water use efficiency. Participatory groundwater management to enable groundwater users in those tank systems that are subject to groundwater stress to improve the management of their groundwater resources and thereby enhance their agriculture productivity. Thirdly was agriculture livelihood support services to enhance tank-based livelihoods by increasing production, productivity and profitability of the agriculture, horticulture, fisheries livelihood and other significant productive activities. MSV's role in the ACTMP project was repairing and rehabilitating almost 3,000 minor irrigation tanks with a command area greater than 40 hectares, covering 2.5 lakh hectares on a sustainable basis. MSV provided third-party quality control and quality assurance services for Unit 4 and Unit 5 for rehabilitation of the tank systems and implementation of tank safety remedial works under the AP-CBTMP. The services provided by MSV on the Andhra Pradesh project were design review and review of project drawings to ensure that the quality of works along with workmanship is conforming to technical specification, to ensure sound construction procedures including deployment of state-of-the-art engineering instruments, to undertake monitoring of the quality of materials used, to carry out field tests required for assuring the quality, to suggest measures for rectifying the defects, to inspect the works and design aspects and suggest improvements, to check the accuracy of methodology and equipment used in QC labs, and to build capacities and provide professional training. The outcomes of ACTMP after we provided services to the Andhra Pradesh government were: firstly, agriculture and water productivity. Rice, paddy, maize, groundnuts and vegetables saw a productivity increase varying from 36% to 40% respectively against targets of 25 to 30%. So we exceeded the expectations. Water productivity calculated as crop output per unit of water from groundwater irrigation increased by almost 40%, exceeding the targets of 10%. Crop diversification. Rice paddy covered 75% of the cultivated area against a target of 66%, though results were better than expected in some drought prone areas. Marketing produce. The creation of commodity interest groups helped increase the final sale value of rice paddy, groundnut and maize by 9 to 17%. Fisheries. All the tank based fishing communities adopted improved fish production and harvesting techniques against a target of 80%. Fish productivity increased steeply by 324%. The project also generated employment of approximately 1 lakh fishers who were landless and belonged to weaker sections of the community. Now, the second important project that I would like to talk about is the Odisha Community Tank Management Project. A background of the project is the tank irrigation systems in Odisha are centuries old. The tank system structures were mostly constructed under the kingship to support the basic human needs of drinking. There were about 3,600 tanks in the state of Odisha. Government of Odisha, with funding from World Bank, undertook to repair and rehabilitate approximately 320 minor irrigation tanks having a command area of 40 hectares to 2,000 hectares under the Odisha State Community Tanks Management Project, OSCTMP. The project covered 64,000 hectares in 12 districts of Odisha and about 111 minor irrigation projects were proposed to be rehabilitated for QA/QC, and 55 were under the northern districts of Angul, Jharsuguda, Bahalgad and Balsavar. Now, the principles underlying the project design were a decentralized mechanism where the main tank beneficiaries play a productive role in planning, implementing and sustaining project interventions. The tank system rehabilitation work meets technical quality and safety standards and pays adequate attention to social, environmental and fiduciary considerations to improve agriculture technology and practices. MSV played a crucial role in OCTMP project. MSV was hired as an expert consultant for this World Bank funded project to provide third party quality control and quality assurance services for rehabilitation of the tank systems. MSV provided similar services that we provided for the Andhra Pradesh tank management project, which I just discussed in the previous slides. And here also there was a remarkable change in the overall productivity in crops in Odisha. With this, I would like to sincerely thank CIDC for giving us an opportunity to present our credentials in the irrigation and agriculture sector in this prestigious ICW Conference 2020. Thank you all. At the outset, we would like to congratulate CIDC for organizing one of the biggest online digital conferences which will benefit the construction industry as a whole. During COVID times, when movements are restricted to a big extent, the efforts of CIDC team is really commendable. We appreciate that the platform hosted so many professionals, experts, industry groups from the construction sector and allied industries who identified key issues for an intelligent discussion and at the same time shared their expertise through this platform. We thank CIDC team for encouraging us to participate in this mega digital event. We presented our vivid experience in numerous sectors of civil and agricultural engineering and also got an opportunity to share our rich experience and expertise in highway, irrigation and other related sectors. MSV believes in a partnering philosophy and have partnered with more than 200 firms from across the globe for taking up large infrastructure projects in India and abroad. We extend a warm welcome to the participants of ICW 2020 for joining hands with MSV for taking up large projects worldwide. With this, we once again thanks CIDC for organizing this mega event. It was our pleasure to be part of ICW 2020. Thank you so much.
Namaskar. My name is Sunil Mahajan. I'm additional DG of CIDC. After graduation from IIT Kanpur and with an MBA in between, 23 years in industry, I joined CIDC at the turn of the millennium, year 2000. This 5-day event is drawing to a close and we are heading towards the final session. I won't say concluding because construction is an unending activity. It is time to say thank yous and till we meet again. We don't believe in goodbyes. And why is that? Construction is a large field and needs to grow even larger and better. So everyone who has joined us in this event is forever on a part of our family. Anytime anybody wants to do anything for improvement or expansion of the industry, you are welcome. You are welcome to join hands with us and we can mutually support each other for this purpose. Specifically in the agro-technology and infrastructure sector, this was a steering group which was set up under the command of chairmanship of Padma Shri Professor Brahma Singh, who has also many other laurels to his name. And under his able leadership, we had superb presentations by Shri C. Devarajan, by Shri Pushkar Malik, Shri R.K. Singh and Shri Lakshman Kumar Palata Singh. Shri Lakshman Kumar is a former Deputy Director of Agriculture in Epicol. Shri R.K. Singh is Project Coordinator in AI All India Coordinated Research Project on Plastic Engineering and Agricultural Structures and also an expert in post-harvest engineering and technology. Mr. Pushkar Singh is the MD of MSV International India, an eminent company which is also highly involved in agriculture technology. And to top it all, we have our mentor, a guide for the entire event and otherwise for CIDC, Shri C. Devarajan. He is the MD of one of the largest construction companies in India, URC Construction, and has extensive interests in agriculture. He is one of the prime applicators of technology in construction in all his agriculture enterprises. We also had a session on air conditioning and refrigeration, which is going to play a very major part in when we expand our agricultural technology. We will need a series of cold chains, a series of climate-controlled warehouses, and in fact, I'll be coming to that later. The session and the steering group for this segment were headed by an IIT Kanpur graduate, Shri Vikram Murthy, who is a first-generation entrepreneur and has expanded his business tremendously in air conditioning and refrigeration. We had the head of president of ISHRE, Indian Society for Heating and Refrigeration and Air Conditioning, Shri Richi Mittal, who gave a very inspiring 5-minute speech. Mr. Shri Jitendra Bhambure, from Rama Manufacturers Association, Shri Vishal Kapoor also from ISHRE, and Shri Ellen Krishna from Rama, and the president of RATA, that's the Traders Association. Rama is the Manufacturers Association. So we've had the representation of all the three associations of air conditioning people in India. The national president of RATA gave an amazing and
very good evening, ladies and gentlemen. The ideas which we plan to convert into many touch points in the future, where all of us will, and then this is going to be put in infrastructure, and the others put together this session. Jain from Twasta Manufacturers, Professor Santosh Kapuria from CSIR Structural Engineering actually change many of the collaborating during the sectional committee. Mishra from Algo 8, Prof. Jail Nora and from Anupama Kohli, and additional committee meetings who contributed to the development of the thought, the idea, and you saw the execution. All this during the times of disruptions, as they say, that change, they used to say that the change is the only constant, but today it seems the pandemic has taught us that disruption is the only constant. So the only way forward is that all of us need to align ourselves with the new normal. We need to scale up our capabilities. We need to actually change many of the things that we've been doing and align them with technology. As disruption happens, emerging technologies are there to support you. So these two things need to be, the disruption needs to be aligned with technology, and you need to do some crystal ball gazing to see the next bend in the road. All this could not have been possible without the able support of our sponsors. I must thank people and patrons from Apple Chemie India Private Limited, Ircon International Limited, Gulf P Global Asphalt, GR Infra Projects Limited, Sudhakar Pipes and Fittings, Afcons Infrastructure Limited, Shapoorji and Palanji, Fenesta Windows, Building Architecture and Engineering Chennai, and CQRA Pune for their wholehearted support and financial support that they have provided to this event. Going forward, I request all of you to keep yourself abreast with the latest that would be happening in your groups. We've already had the WhatsApp group, and that's we try to basically keep you updated through that communication. And off and on, we would also be writing detailed mails and talking on phone so that the connect remains intact. So whatever your thoughts, whatever your feedback, whatever queries you have, do share with us, and that will help us in basically forming the agenda going forward in the next year. This event has taught us that the theme that we had in mind, revival of the construction industry post-COVID, the COVID, it's not over as yet, but then we've had despair and then we have a lot of hope. Perhaps the vaccine is on the cusp of delivery and soon we may have a medication as well. But all along, during the pandemic, one thing that all of you have done is work on your immunities, build your systems to fight the pandemic. And that is what these events are meant for, so that we all contribute in thought and process and we strengthen the construction industry per se through our contributions, through creating replicable best practices. So wonderful people, thank you so much for your contributions to the event, and I wish you season's greetings and best wishes for a very happy new year in advance. Thank you so much.
Ladies and gentlemen, good day to all of you. I am Rajiv Jain, Director Training CIDC. Time doesn't stop is a universal truth, and we have to manage our activities in accordance to the movement of time. I am happy to share that with the support and active participation of all of you, we could manage this 5-day mega event well within time. The learned speakers from around the country and around the globe have shared their experiences on different aspects of construction industry, and also they have shared during the crisis of this ongoing pandemic how their respective countries are managing to cope this current crisis. The event had multiple parallel conference tracks, and I had been personally coordinating steering committees on 3 of the important tracks. These were concrete technology, real estate, and skilling initiatives in India. I must say, the concrete chairmen of these committees have put in their best efforts to bring in the most desirable topics for deliberation and the most competent experts to talk about these issues. I am sure the delegates and the participants must have enjoyed the sessions of their interest. Let me share with you all that technical presentations will remain active on this portal for yet another 2 months, and the presentations you have missed could be enjoyed again at your convenience anytime during this period. All the queries you might have may be directly emailed to the respective speakers and copied to CIDC. The details of individual speakers are available in the archives on this portal. Now, while concluding my talk, I hereby acknowledge the most humble contribution and untiring efforts of Dr. S.K. Manjrekar, Managing Director, Sunanda Specialty Coatings Private Limited, who had chaired Steering Committee on Concrete Technology. Also, Shri B.D. Mundra, Chairman and Managing Director, Simplex Infrastructure Limited, who had chaired Steering Committee on Skilling Initiatives. I am also thankful to Shri Velamati Ramnath, Chairman Andhra Pradesh RERA, and he chaired the Steering Committee on Real Estate. I am deeply thankful to all the 42 speakers from India and abroad for sharing their valuable knowledge and contribution on concrete technology and post-COVID recovery mechanism adopted in their respective countries with all our participants. Further, my heartfelt thanks goes to all the learned speakers for enlightening us on issues related to skilling initiatives and changed dynamics in the era of COVID-19. I am also grateful to the learned speakers for raising the issues related to the real estate sector and proposing their viewpoints on how to amicably resolve all these issues. I am also thankful to all the sponsors and exhibitors. In particular, my thanks goes to Andhra Pradesh RERA, Himachal Pradesh RERA, Chhattisgarh RERA, and Ardex Endura for their valuable contributions as sponsors. Last but not the least, I wish to thank all the participants, my colleagues, for their active and untiring efforts to make this event a great grand success. Thank you all, stay safe and remain connected. Jai Hind.
Good day to all. Now that we have concluded both the sessions on disaster management, I'd like to place on record my sincere thanks to all the experts for providing us insight in this post-COVID scenario. However, with the presentations, we have come to realize that COVID is not the only thing to be worried about in these times. There are other disasters which have been identified, solutions given, and also the action points have been discussed. I would like to thank our experts, Dr. Chandan Ghosh, who is also the chairman of the steering committee, and he delivered the presentation on disaster resilient construction, a step towards sustainable habitat. Mr. Amandeep Garg spoke upon how construction sector could help in disaster mitigation and contribute for the growth of the nation. Dr. Krish Chandra shared his experience on owner-driven construction houses. Mr. Rajendra Desai spoke about building artisan education program and also on retrofitting of museum rebuilding, why and how. Dr. Nilima Satyam told us about advances in ground improvement, biogeotechniques of granular soils. Dr. Pramod Deshpande spoke on risk assessment and risk management approach for construction business in the post-COVID scenario. Dr. Abhijit Ganguly delivered his presentation on non-destructive testing and concrete infrastructure industry. And Engineer Vijay Gupta spoke on disaster management, whereas Dr. Hemant Kumar Vinayak shared his thoughts on construction beyond municipal boundaries of Himachal Pradesh, which was really an issue of concern. Mr. S.K. Dhawan spoke on construction management issues. I'm sure we all learned a lot on mitigation of disasters and how to move forward development of the society. It is my pleasure to share with you that these presentations will be on the site for the next 3 months. I look forward to having all the queries and suggestions on these topics, especially from the students to enable taking knowledge forward. We could also focus on specific programs where knowledge is needed, so I will look forward to your queries on special programs that we can conduct. Thanks a lot for all of you to being with us. Thank you.
Good day, everyone. I am Rajiv Jain, Director Training CIDC. I believe all of you have enjoyed all the technical sessions and it has been a great learning experience for all of you. As we are about to conclude this mega international event, I would like to place on record my heartfelt thanks to all the steering committee chairmen, esteemed committee members, all the speakers, sponsors and exhibitors, and all of you dear participants. In particular, I wish to thank on behalf of my colleague, Mr. Deepak Majumdar, who had been coordinating a few important steering committees. The steering committee on cement was chaired by Mr. Sanjay Mathur, Chief Special Initiatives Officer, Ultratech Cement Limited. He has provided valuable guidance and also highlighted the core issues related to cement industry in India. We express our heartfelt gratitude for him to spare his valuable time and chairing this important committee. We also thank the esteemed committee members who gave their critical inputs to make this track of conference more interesting and meaningful. I am confident that the deliberations will go a long way in highlighting the role of Indian cement industry in the revival of construction industry post-pandemic. I am also thankful to Mr. Y.P. Kajale, Vice President, Engineering Planning and Design, BG Shirke Construction Technologies Private Limited. Mr. Kajale chaired the steering committee on prefab construction and pre-engineered buildings. My thanks goes to Mr. P.V. Rao, who co-chaired this committee and provided the insights of the issues concerning prefab industry. In total, there were 16 speakers for this track of conference. The steering committee on steel was chaired by none other than Mr. Anil Kumar Chaudhary, who is Chairman SAIL, and the committee was also coordinated by Shri Gauri Shankar Dubey, former ED SAIL. The committee discussed the methodology for increasing the consumption of steel in real estate and infrastructure sector. It was suggested that while formulating any projects, the life cycle cost component must be considered invariably. Presenters also discussed about waste management in integrated steel plant for manufacturers. Usage of steel was recommended for rural housing and agro sector. In total, there were 12 speakers in the steel track of conference. I am thankful to all the speakers. Special thanks to Mr. Anil Kumar Chaudhary for his valuable guidance and support. I am also thankful to Mr. Gauri Shankar Dubey for coordinating with the speakers. My thanks to all the esteemed members of the committee and all the speakers and participants. There was another group on international collaboration. It was constituted to create a forum aiming at global partnership, especially amongst the countries in Asian region for knowledge sharing and technology transfer, etc. The group constitutes members, especially from Asia Construct member countries, and invites and support to explore areas of mutual cooperation on the theme revival of construction industry post-COVID-19 by understanding the strategies adopted by the respective countries and policies adopted by respective governments to tackle this ongoing pandemic. The group was chaired by Dr. P.R. Swaroop, who is DG CIDC, and the prominent members include representatives from Hong Kong Polytechnic University, CSDB Indonesia, Philippines Academy of Managers for Construction and Cities, Vietnam CIDA, Sri Lanka, Philippines Overseas Construction Board, Embassy of Philippines, SPIU Uttar Pradesh, Samrat Ashok Technological Institute, Vidisha. The following important issues were discussed during this track of conference. Effect of COVID, how Asia Construct member countries are handling the pandemic and how the experience could be useful to each other. Human resources, shortage of labor, skill training were among some of the major issues. Industry perspective, recommendations for policy change post-COVID, global scenario, and adoption of new technology and good practices. I am confident that the International Collaboration Group will take a lead in providing the blueprint for action and way forward for the revival of construction industry in Asian region and globally by creating better opportunities and finding cost-effective solutions through infrastructure development, revising procurement practices, capacity building, and so on. I thank the chairman and members of the committee for sharing their knowledge and providing inputs for taking it forward. We also express our thanks for the patronage of our sponsors, without which this conference could not have been successful. My thanks goes to Institute of Lean Construction Excellence, JK Cement Limited, BG Sirke Construction Technologies Private Limited, URC Construction Private Limited, Steel Authority of India, Dextra Group, Ultratech Cement Limited, Ready Mix Concrete Manufacturers Association. Lastly, I would like to remind you that the pandemic is still on. Take care of yourself, keep learning and improving the living spaces around the world. Thank you once again. Thank you all. Jai Hind.
I'm sure at the end of it, we would be able to have clear action plans for the central, the state government and the stakeholders to move ahead. I take this opportunity to profusely thank the Goa government for its support and sincerely appreciate the tremendous efforts put in by Dr. Swaroop and his team, including Mr. Samir Sulakar and Mr. Rasik Naik, in organizing and making this event happen. Finally, on behalf of Vibrant Goa Foundation, I would like to wish all the delegates the very best and hope you will have a highly productive conference. Thank you all.
On behalf of Construction Industry Development Council and Indian Society for Trenchless Technology, I, Pawan Kumar Mishra, Additional Director, would like to express our sincere gratitude to all who have contributed directly or indirectly to organize India Construction Week 2020. India Construction Week 2020 has been divided in several streams to cover the entire spectrum of construction. Academia is one of them. I would like to express my sincere gratitude to Professor P.K. Garg, Vice Chancellor, former Vice Chancellor, Uttarakhand Technical University and Professor, IIT Roorkee, for his humble but great leadership to organize the academia stream of the ICW 2020. Professor Govind Pandey, co-chairman of the steering committee, and the other members of the steering committee like Professor Santosh Kapuria, Director CSIR FERC Chennai, Professor N. Gopal Krishnan, Director CSIR CBRI Roorkee, Professor Manu Santhanam, IIT Madras, Professor Bharat Lohani, IIT Kanpur, Professor Rajan Chaudhary, IIT Guwahati, Professor J.S. Chauhan, Director, SATI Vidisha, Professor Chandan Das, IIT Jammu, Dr. Anil Kumar, SPA, SPIU, Uttar Pradesh, Dr. Ajay Chaurasia, CSIR, CBRI Roorkee, Dr. M.K. Shrimali, NIT Jaipur, Dr. P.K. Ramcharala, Triple IT Hyderabad, Dr. Ramkrishna Baig, IIT Patna, Professor Aldo T.I., IIT Bombay, Dr. Nilima Satyam, IIT Indore, Professor Devendra Mohan, IIT VHU Varanasi, Professor N. Raghavan, IIT Madras, Professor Farad Das, IIT ISN Dhanbad, Dr. Avijit Ganguly, IIT Tirupati, Dr. R.N. Khare, Principal, VSC, Lakhanpur, Chhattisgarh. All these are the members of the steering committee and they have contributed a lot. They have spared their very, very valuable time to organize successfully the India Construction Week 2020. We are very thankful to our National Action Group chaired by Professor J.S. Chauhan and other members in Action Group. We are privileged to share that the professor and senior faculties from almost all IITs, all NITs and very great institutions are the member of our National Action Group. Our sincere thanks to all of them for their very active roles in the India Construction Week 2020. We are privileged to inform that more than 10,000 academicians, faculties, and students have been actively participated in the ICW 2020. We are also very thankful to all speakers. We have received more than 50 technical presentations from, again I am repeating, from almost all IITs, NITs and big institutions from all states of the nation, from all parts of the nation. We have received the technical presentation. We are very thankful to the contributors, to the speakers for sparing their valuable time, for sharing their very great and valuable information and knowledge. We are very grateful to all of them for their active participation. We are very thankful to state project implementation units, especially Uttar Pradesh, Bihar, Madhya Pradesh, Jharkhand, Odisha, Jammu and Kashmir, Rajasthan, and Himachal Pradesh for their coordination with institutions, faculties, and students, and for providing the opportunities to the students to have support, financial support from the TechUp Fund. We are very grateful to all of them. We are really very grateful to all of them. Thanks to all. Dear Sir and Madam, I, Pawan Kumar Mishra, Additional Director, CIDC, is expressing this sort of thanks message on behalf of Professor O.P. Gupta, VSM, Acting Registrar, CISE. Respected Dr. Udesh Kohli, Chairman, CISE, and Dr. P.R. Swarup, Member Secretary, CISE, dignitaries for the valedictory session, ladies and gentlemen. I am honored to get an opportunity to thank you all on my behalf and on behalf of CISE in the capacity of Acting Registrar, CISE, on the concluding day of the 5 days events India Construction Week 2020 Digital Conference and Exhibition. This event consists of several segments including CIDC, CISE, dispute resolutions and arbitration. There are 30 papers on negotiations, mediations and arbitrations, including 3 from foreign, USA, Ms. Aina Duggal, and Singapore, Barrister Jamshed Piru, Advocate Dr. Renu Rao London, and all the states and union territories from India. The videos presented are from veterans in their own fields like town planning, architecture, chartered accountants and income tax, litigations and ADR, joint venture disputes, online dispute resolution, how to make India an international arbitration hub, methodology to be adopted for dispute resolution post-COVID-19, critical analysis of arbitration acts and its amendments, contract law and its drawbacks, remedies, and so on. I would like to thank all the authors, speakers, and members of the organizing team of the event for 5 days in the front row and in the green room, particularly Mr. Anand. I especially thanks to Engineer A.P. Radhakrishnan, Chennai, for getting principal partner AFCONS, and Engineer H.K. Verma, Coordinator Odisha, for arranging messages of Honorable Governor, Honorable Chief Minister, and Honorable Minister of Panchayat Raj of Odisha. Heartfelt thanks to all 284 impaneled arbitrators and mediators and 20 coordinators from states from North, East, West and South, PSUs and professionals for their wholehearted support and participation. I will be failing in my responsibility if I don't thank to Dr. Niranjan Swarup, Dr. Suchita Kumar, Engineer P.K. Mishra, Ms. Lakshmi and Ms. Jyomiti for their relentless support. My sincere thanks to them. CISE appeal and impress upon all the government departments and PSUs for encouraging institutional arbitration for dispute resolutions by incorporating such CISE arbitration clause in their contract documents, because CISE is pride and reputed arbitral institution in India. CISE further requests all the stakeholders that two-tiered arbitration clause be not provided in the contract, particularly in international contracts, because the same is not in the interest of any party and India. I would like to express my sincere thanks, my sincere gratitude to all of them, to all of them. Thanks, Professor O.P. Gupta, VSM, Acting Registrar, CISE. Thanks to all.
Dear friends, a very good morning. I take this opportunity to welcome all the participants and delegates to this very important topic, reviving construction industry in the post-COVID world, jointly organized by CIDC and the industry. We have all seen this unprecedented global pandemic striking us in early 2020 and bringing the global economic scenario towards standstill. The crisis, one of the largest since the Great Depression, impacted all countries, rich and poor, developed, undeveloped, and emerging economies. Millions of people have already been infected by this COVID crisis and across various geographies, and few lakhs have not survived to see the post-COVID world. This has greatly impacted government fiscal situations. Companies have had to change their business models. Social issues of growing unemployment, reducing earnings, expenses on healthcare and social security, etc., have altered the buying behavior of consumers. Certain sectors like tourism, hospitality, airlines, etc., have been hit very hard. However, every such major disruption is an opportunity to bring about a change in business models, recast plans, revamp supply chains, develop new products to cater to a new emerging market. Innovation, adoption, and adaptation are key elements to look at the new normal. We have seen work from home, radical increase in digital intervention, use of technology to drive e-commerce, use of digital platforms like Zoom and Microsoft Teams to connect globally, etc., have all grown in geometric proportions. Having seen this crisis, the construction sector has also witnessed some very challenging times. The sector saw crashing of the construction work on sites. In fact, the lockdown in March and April saw all construction activities coming to a standstill. Factories had to stop production, supply chains got stuck, huge inventory of unsold stocks, rising working capital, and a financial crisis being faced by the industry. The steep fall in the financial markets, which was witnessed, the stock markets crashed world over on the fears of uncertainty and financial crisis. The first 3 months were frightening, uncertain, and fearful. There was drastic reduction in spending, consumer behaviors. In fact, most people were seeing this gloomy situation, and they were wanting to curb all extra expenses to save for the future. However, after 3 months, that is after July end, August, certain green shoots were visible. And I think this was a result of the ability of human nature to adopt and adapt very fast. I think the first 3 months were basically adoption and adoption of new techniques to survive and to work. Now, the cement and concrete industry has also been no exception. Like any other industry which was impacted, the cement and concrete industry also went through this gloomy situation. In March end, when the crisis struck, plants got stopped. There was huge inventory on road, on rails, especially of cement, and So that really created a panic situation because people were uncertain as to what to do. But thanks to the very agile nature of mankind, I think everybody came together, put their heads together, and came out with solutions to really tide away this situation. Today morning, I have a panel of very distinguished and experienced experts from the cement and concrete world. We have Mr. S.V. Patil, who is the head of RMC Ready Mix Concrete and Key Accounts Business at Ultratech. Mr. Ramesh Joshi, who is the current president of the Ready Mix Concrete Association of India and also a senior vice president with Ultratech. He's been a pioneer with the Ready Mix Concrete division of Ultratech and been with this division for the past 20 years. We have Mr. Atul Desai, who is the executive director and CEO of RMC India, which is again a very large concrete company operating in India, pan-India operations. And we have Mr. A.K. Jain, who is well known in the field of concrete and cement technology. He has spent most of his time in the military engineering services and then later on with Ultratech as a consultant. I welcome all the panelists to today's discussion, and I would request you to kindly take us through 4 major events which have happened. How has the cement and concrete industry come out of this gloomy situation? How will the cement and concrete sector be a strong partner to India's dream of a $5 trillion economy? The third question would be, what changes are we seeing in consumer demand and consumer behavior, new innovations, new products and technology, and the use of green cement, that is the increasing use of blended cement. And if you have to sum up the entire thing, what are the key learnings of this crisis, which will actually go a long way in really enabling other industries or other related construction sector people to see as to what all has happened in the cement and concrete world, and if there are any learnings which can be implemented or used by the other sectors. So on that, I would like to welcome the panelists and take this discussion forward. Thank you, and I hope all of you have a fantastic time in this conference. It's a great event, and I think it will give an opportunity for all of us to discuss what the future lies in store. Thank you.
My name is Samir Sullakar. I represent the construction chemical industry, which is directly dependent on construction industry, be it infrastructure or real estate. What a grand show we had in India Construction Week. Fantastic response. First of all, I congratulate Dr. P.R. Swaroop for conceptualizing such a cross-functional and multi-pronged program during these tough times with a view to revive the economy. A timely initiative, a great work, a great thinking. We had excellent contents on all forums, like in the construction chemical session, in concrete session, in emerging technologies session, in skilling, in machineries, as well as machineries and other related topics. We now have a collection of ideas and technologies put forward by professionals, academicians, and experts, which can form a base for developing a blueprint to revive the economy in days to come. I appreciate very hard work put by CIDC team as well as the team of Indian Society of Trenchless Tunneling for the Nordic show with excellent coordination and follow-ups, and this was the reason for the grand success that we had. Event of such a nature, it was on a large canvas, and we have done very well. This initiative is just a beginning or a first step towards working on our common goal of revival of economy, which is very important for our industries not only survive in days to come, but also to flourish and get back to the olden times, or the golden times now you can say. Congratulations to the organizers for grand success of India Construction Week 2020 and Nordic Show. Great contribution to civil engineering industry, as well as this was an excellent forum for students for learning and absorbing about new technologies which they can use in their internship programs, and maybe they can even add in their curriculum at the college and the postgraduate and doctoral levels. And these topics can be also used for skill development. Some technologies which we covered, they can be used by young engineers to turn into entrepreneurs. With the training and with the machineries and the other type of techniques and knowledge about materials, they can be a good entrepreneurs, because it is nowadays in this time getting jobs is a bit difficult, and this is a low entry field. So I wish also the student fraternity and the new engineers all the best. At the end of the day, it was a great show. It was an excellent show, and we really had a great learning experience. Congratulations to all involved. Thank you.
Hello and good morning. I'm Himanshu Kapadia, and today I'll be discussing some of the smart systems for building envelope. Let me try to share my screen with you so you can see the content. What we are including today is some high productivity waterproofing systems, how to get comfort at lower energy cost with insulation systems, peculiarity of the precast structures, and based on what we discussed, setting the tone for future. The challenges we are faced with today are linked to a shortage of everything we have around us. Shortage of money, shortage of time, shortage of skilled laborers, and on top of it, a lot more freedom demanded by our designers, because we keep changing the usage of the building even before it is constructed. You're constructing a commercial building, and then midway you decide to convert it into the hotel, or you decide to put a swimming pool in the basement or a jogging track on an intermediate floor. All these challenges demand different solutions than what we have been doing, and yet we have to keep our eye on the capital employed. And needless to say, earlier we complete the project and operationalize, better is the return on the capital employed. When it comes to waterproofing, our age-old practice is to use the stone cladding or mud fusca or the brick beds. They are all very slow and inefficient systems. A crew of 10 to 15 produces just about 100 or 150 square meters in a day, and the overall operation can take as much as 2 weeks to complete. Of course, there have been changes with time. We have had other chemical systems coming in, which you have to brush apply or roller apply or torch on, but none of them are either as efficient or long lasting. Modern chemistry solutions allow us to adopt new methods, for example, spray applied materials, where just a crew of 4 people can do about 1000 square meters in a day. So 1/4 of the skilled labor required to do almost 5 to 6 times of application in a day's time. Various solutions available. I would pick one for discussion today, which is polyurea hybrids. From acrylic cementitious material, we moved on to polyurethanes long time ago, which had great amount of flexibility, but not so good mechanical property. And then came hot applied polyurea with great mechanical property, but not so much flexibility. A hybrid which combines the advantages of both can last for as much as 25 years, 30 years. It can be applied much faster. This will be my proposal for today. But the story does not end here. It's also connected to the installation. Material alone can only give you a certain amount of assurance. The installation capability is another big factor in successful waterproofing application. When the leakage takes place, your installer, provided you have a good installer, will come and seal the leakage. But water has already entered. If it is an infrastructure project designed for 100 years or 120 years life, the deterioration of the structure has already started, the reinforcement corrosion starts, and your expected service life comes down. If you're running a hotel, as I'm presenting in this case here, which is based on a real case in Bangalore some time ago, 20 leaking rooms ended up having 2.3 crore cost in repairs, refurbishment, and loss of revenue for 3 months. The devil is in detail. A good installer understands how to terminate joints, how to use the right material in the right way. Our clients often look at the warranty paper while deciding the installer, but warranty is just a paper. It cannot prevent all other losses if the leakage takes place. So we have to be very careful while evaluating the capabilities of the installer. Let's move on to another important aspect, which is the energy consumption. We know the impact of climate changes. Summers are getting hotter, winters are getting colder. There's flood taking place even in the cities where the water table used to be very, very low in the earlier times. We build urban heat islands. I'm sure you all know about this term, where the tall buildings, dense infrastructure increases the ambient temperature by as much as 6 to 8 degrees compared to rural areas. Now the whole world is talking about reducing the carbon footprint and bringing back the climate or having the climate control to stop further deterioration. India has also signed into these global protocols, and in turn, our government, our controlling agencies have also come up with measures. So ECBC, for example, has come up with their guidelines to reduce the energy consumption into the buildings. The ECBC guidelines primarily divided into 3 different categories of codes depending on the location, type of building, and the primary code, the ECBC guidelines, are mandatory if the commercial structure, commercial building has at least 100 kilowatt of the connected load. What these guidelines prescribe? They prescribe U value, which in a way is the measure of energy consumption per unit volume of the building. Certain building types, for example, hotel or the hospitals where the air conditioning runs 24 hours, the requirement is even stiffer. And this is progressively being made stiffer. So we are looking at 2 aspects, waterproofing and the insulation, to reduce the energy consumption in the building both at the same time. The insulation can be achieved by using a variety of materials. On this slide, on the right side, I'm showing you a chart which gives the efficiency of different types of insulation material. Polyurethane foam, PUF as we call it, is the most efficient insulation material available today. What you can see here is the other materials or the thickness of the other materials required to meet the same insulation property as polyurethane PUF. A 50 millimeter of the foam gives the same insulation as 1.8 meters thickness of brickbat coba. Of course, we won't do that much thickness, and all other materials in between. And where do we apply these materials? Do we do it above the deck or below the deck? The best answer is to do it above the deck, because you are preventing the heat penetrating into the substrate roof material. Of course, if done under deck, not only we don't prevent the heat coming in, but also it's a lot of inconvenience depending on the usage of the area where the underdeck insulation is done. I remember a case a long time ago when I was just new into the civil engineering industry. The organization where I was working, we had to reconstruct the whole roof slab where the underdeck insulation was done. The leakage from top accumulated between the insulation and the roof slab, corroded the whole reinforcement, and it resulted into replacement of the slab. As I mentioned earlier, the combined waterproofing and insulation for the maximum effect is the best way forward. For the commercial structures, a combination of good waterproofing material like the polyurea spray and PUF with about 50 kg per cubic meter density, closed cell content of 90 to 95% is the best solution. In about 50 to 80 millimeter thickness, you can achieve desired results. And where the demand is not so high, we can also use thin sprays of slightly higher density of foam. Now, the advantage of this higher density foam, roughly about 60 kg per cubic meter, is that it itself is also a waterproofing layer. So say about 10 to 30 millimeter thickness will give desired result, saving 40 to 80% of the heat gain. Let me show you a video which shows the spray of this thin applied higher density foam. Great. The building envelope is not complete if we don't talk about the walls. The roof and the wall together is the source of almost 70% of the heat gain. I understand there's another presentation on walling systems, the external insulation and finishing systems in this conference. So I'll not get into the details. I'm proud to show you the picture of this hospital in Faridabad, which used about 6,000 square meters of external insulation on the walls. Let's move on to another trend for rapid construction, which is precast. Saves considerable time. We started long time ago replacing element by element in a cast in situ structure, the columns, and then came the beams, then came slabs, and now we are having even the bathroom pods and the three-dimensional structures like staircase. So a building is actually being built like a Lego system. What challenges it poses for the leakage prevention? It's not only the thermal stresses, but also the deflection, which starts becoming a big consideration while designing waterproofing for the precast structures. We have one more challenge. In the precast structures, work once done determines how good is going to be the performance during the service life. Extremely difficult to find the source of leakage after the structure has been put to use. So design, in fact, the waterproofing also has to be designed with the same level of seriousness as the precast structure. And we also see what is happening in the market at the moment. To save time, our constructors convert from the cast in situ to the precast structure, but every other specification remains almost similar. So the same waterproofing which was chosen for the cast in situ structure goes into the precast structure, and then we have incorporated problems right from the day one. What essentially precast structure demands is the greater flexibility in everything we use. The joints are extremely important. They need to be sealed with flexible materials, multiple types available. I'm talking about here polyester, thermoplastic elastomeric material for precast joints. They are embedded in the PUR system, the PUR waterproofing systems, which you apply for waterproofing. We have to ensure that we use flexible tile adhesives and we use bond breaking tapes on the corners. So talking to installer and talking to the material supplier right at the time of structure is a prudent way of sealing the precast structures. Having covered the aspects of waterproofing, energy saving using insulation, and the critical aspects of precast, I would come to the end and summarize what we discussed. The industry mega trends, if I had to capture in 4 words, these are safety, durability, productivity, and sustainability. And then the owners have to juggle with the aspects of time, money, and resources while taking decision on any system being used. The result of this mega trend in the way we will do the selection and apply materials in future is looking at the productivity, mechanized methods, old systems like brickbat Koba being replaced with high productivity systems like polyurethane, polyurea spray applied systems. Far bigger focus on energy saving. In fact, my recommendation also to the government would be to upgrade all the buildings and reduce energy consumptions. While I was posted in Singapore and looking after the business in China, I was involved in the projects having millions of square meters of external insulation being done onto the government buildings, only because China also wants to show to the world that they are serious about the climate change. Durability plays important role, and we must start looking at the life cycle cost and not just the initial cost. The capability score for installers, they should be incorporated in the vendor selection and not just the lowest price. That would be a pragmatic approach. And then the aspect of sustainability, increasing use of materials locally produced so that we have lower carbon footprint, less emissions in carting the material to the project sites, lower toxicity, material having less volatile content, new and environment friendly construction practices. So precast, for example.
Hello, ladies and gentlemen. As we all know, the world is facing a horrid time due to COVID-19, and the construction industry also has been adversely affected by this pandemic. There are many challenges. Hello, ladies and gentlemen.
Namaskar. My name is Sunil Mahajan. I'm additional DG of Sales.
Good evening, ladies and gentlemen.
Ladies and gentlemen,
I'm sure.
Respected Dr. Udesh Kohli, Chairman CIAC, Dr. P.R. Saroop, Member Secretary CIAC, dignitaries for the valedictory session, ladies, gentlemen, I'm honored to get an opportunity to thank you all on my behalf, on behalf of the also CIAC. On the concluding day of 5-day events, India Construction Week, Digital Conference and Exhibition. This event consists of 14 segments including CIADC, CIAC, Dispute Resolution and Arbitration. There are 30 papers on negotiation, mediation, arbitration, including 3 from foreign USA, Singapore and London, and all the states and Union Territory of India. The video presented are from veterans in their own field like town planning, architecture, chartered accountant and income tax, litigation, ADR, joint venture dispute, online dispute resolution, how to make an India an international hub, methodology to be adopted for dispute resolution, post-COVID-19, critical analysis of Arbitration Act and its amendment, contract law and its drawbacks and remedies, and so on. I would like to thank all the author speakers and members of the organization team of the event for 5 days in the front row and in the green room, particularly Mr. Anand. I would also like to thank all the authors, speakers, members for, especially I thanks to Engineer A.P. Radhakrishnan, Chennai, for getting Principal Partner FCON and Engineer H.K. Verma, Coordinator Orissa, for arranging messages for Honorable Governor, Honorable Chief Minister and Minister of Panchayat Raj of Orissa. Heartfelt thanks to all 285 impaneled arbitrators, mediators and 20 coordinators for state 18 for new north, south, east, west, and 1 from public sector undertaking and 1 from professionals. I will be failing in my responsibility if I do not thank Dr. Niranjan Sood, Dr. Suchita Karmar, and P.K. Mishra, Mrs. Lakshmi, and Mrs. Jayanti for their relentless support. My sincere thanks to them. CIC appeal to impress upon all the government departments and PSU for encouraging institutional arbitration for dispute resolution by incorporating such CIC arbitration clause in their contract document, because CIC is pride and reputed prestige arbitration institution in India. You may like to know that CIC is the only authority which has started international arbitrations, institutional arbitration as early as in 13 January 2013. Many were conducted on institutional and ODR system. There were 2 sessions. One session was in the morning and the second was in the evening. The first session was inaugurated by Dr. Ahmed Mahmood, Secretary General, Asian Pan-African Legal Council, and while the evening session was inaugurated by Mrs. Meera Agarwal, North Delhi Municipal Corporation Mayor of that. On 16th February 2016, we again hold another international seminar, and all the seminar was jointly with the UNSTAR. That was inaugurated by the Law Minister and Ministry of Law and Justice, Mr. Sadanand Gowda. And the third, dispute resolution mechanism. It was discussed on ODR, and that was inaugurated by the Honorable Vice President of India. During the launching of the portal for the ODR, the Honorable Vice President opined that CIC is the only authority which are initiating for ODR mechanism. Not only that, whatever they are training the students category, they will avoid the unemployment in the country. Apart from that, I may add that this is the institution which has been notified by the Law Ministry on 21st August 2017. We have taken the training not only in India, but we have taken the training of the empanelment of the arbitrator at Bhutan. Thank you with all the honor. Thank you.
very good evening and a warm welcome to all of you on this valedictory session of India Construction Week 2020. On behalf of Construction Industry Development Council and the Indian Society for Trenchless Technology and our entire team, I am delighted to offer a gracious welcome to all of you. The sequence of this valedictory session will be: first we'll begin with the customary lighting of lamp, followed by address by Dr. P.S. Rana, Chairman of Construction Industry Development Council, address by Dr. B.D. Mundra, Mentor of CIDC and Chairman Simplex, address by Mr. Ehtesham Ul Haq, Managing Director DCI, address by Mr. Sunir Garg, Director Technical, address by Mr. Craig, Chairman NASTT USA, then address by Mr. Devarajan, Managing Director URC Construction Limited, followed by address by Mr. V. Ramnath, Chairman of AP RERA. We have then message by Mr. Pratap Jena, Honorable Minister Panchayati Raj and Drinking Water, Law, Housing and Urban Development, Government of Odisha. We also have a message by Mr. Naveen Patnaik, Honorable Chief Minister, Government of Odisha. We then have address of the Chief Guest, Honorable Justice Gyan Sudha Mishra, Justice Supreme Court of India, retired. We have few messages then from the delegates of this conference, and then we have vote of thanks by Dr. P.R. Swaroop, Chairman of Indian Society of Trenchless Technology and Director General of Construction Industry Development Council. Finally, we have the vote of thanks by Professor Niranjan Swaroop, Director General of Indian Society of Trenchless Technology.
Shubham kurutvam kalyanam arogyam dhanasampadah. Shubham kurutvam kalyanam arogyam dhanasampadah. Shatru buddhi vinashaya deepajyotirnamostute. Deepajyotirnamostute. Shubham kurutvam kalyanam arogyam dhanasampadah. Shubham kurutvam kalyanam arogyam dhanasampadah.
Ladies and gentlemen, I welcome you all for the validation session of the India Construction Week 2020. These online international conferences and exhibitions held over the last 5 days were organized jointly by Construction Industry Development Council and Indian Society for Trenchless Technology. I am happy to inform you that ICW 2020 had a very wide participation at national and international level. We had active support of over 40 organizations and more than 14,000 delegates. These events have generated total lecture duration aggregated to 147 hours. I am told these recordings will be available online for the next 3 months. The key partners of the event included both public and private organizations such as State of Goa, AP RERA, IRCON, Vibrant Goa Foundation, Consulting Engineers Association of India, Institute for Lean Construction Excellence, Purdue University of USA, International Infrastructure Solutions of USA, North American Society for Trenchless Technology of USA, Center for Underground Infrastructure Research and Education, IKT Germany, International Institute of Utility Specialty Hong Kong. I am happy to note that these 14,000 delegates were from industry, education and research institutions, and a large number of students participated in it. The deliberations focused on the critical issues to chart out the course of action to be followed by the industry to come out of the current state and become vibrant. These programs were divided into two main streams. One, CIDC and associates organizations deliberated and addressed the critical issues facing the respective industry domains and paving the way for their solutions. The second, Indian Society for Trackless Technology organized the No Dig India Show 2020, the flagship annual event of the society. ICW 2020 had several integral events ranging from conferences, live shows, interactive exhibition, live visits to projects and production facilities of exhibitors, technical training programs, and release of guidelines and technical publications. Launch of training portal. The discussions included a variety of subjects such as construction material, construction equipment, emerging technologies, trenchless technology, disaster management, insurance and banking, infrastructure and services, skills and education, tendering, arbitration and consultancy. No Dig India Show 2020 released 4 important documents: the General Contract Document, Special Contract Conditions Document, Schedule of Trenchless Rates 2021, and Site Investigation Manual. I hope the deliberations and recommendations of the conference regarding the importance of good construction practices, processes, and guidelines, and demonstration by the equipment manufacturers about their equipment safety, productivity, and operating procedures will help to achieve quality, productivity, and safety in construction projects. I hope your participation in this conference was very productive and you enjoyed your 5 days of deliberations. I really thank you for your active participation and wish you luck for the future. Thank you.
Good morning, ladies and gentlemen. As all festivals comes to an end, this conference, this Gyanavad Yajna will come to an end. Today there will be Purnahuti in this Yajna. This Jnana Yajna, the main Rohit Yajman was CIDC. This conference was organized by CIDC with the help of Trenchless Technology. Talking about CIDC, which was started, the sapling was planted 25 years before. This grew up under able and dynamic leadership of Dr. P.R. Swaroop, and Trenchless Technology grew up under leadership of Sri Niranjan Swaroop. Now, this organization developed into a multi-dimensional, multifaceted organization. Today, it is widespread. It is having branches and centers all over the country. This was blessed by stalwarts and very knowledgeable, venerable Dr. Ramakrishna, Dr. Udesh Kohli, and today it is being headed by Sri Rana. I have been watching this as a mentor. Friends, talking about this conference, it was momentous. 10,000 registered. There were 3 halls in which parallel sessions, morning to evening, took place. In each session, more than 2,500 to 3,000 participants were present. more than 300 scholars from our country as well as from abroad. They benefited us by their knowledge, by their experience, by their gyan. They covered more than 18 topics, different aspects of it. And friends, we learned quite a new things. I have 60 years experience in this industry. I learned quite a number of new things. And I was fascinated by it. Friends, my preference is always towards skilling and training of staff and skilling of workers. You know, there are 49 million workers in this trade, and 70% of them are unskilled. Only 30% are partially skilled or fully skilled. We require nearly 40% fully skilled people. We cannot afford to have more than 30% unskilled, and balance can be semi-skilled on different aspects of construction. Similarly, our engineers and our staff should be well trained for ground operation. They should know the reality of today's situation. They should blend and take the leadership of the labor. For that, they have to be on same wavelength. They have to speak same link. CIDC has been making the effort in this direction. Of course, some private organizations also did put in efforts. And now, government realizing the importance of skilling and training, have emphasized on it and putting in a lot of money and efforts. And so also state governments and so many private organizations. All these efforts are to be synchronized and are rationalized. Similarly, development of new materials and new tools, we cannot always depend on outsiders. We cannot always import it. So we have to do our own R&D. And this efforts also has to go on. During the course of this conference, we saw so many new products, new techniques, new tools, new machineries. This has to be further taken forward, and efforts are to be made to synchronize the efforts of all the people in the country. Because by synchronized efforts, we get better dividend than separate efforts. It will be a pleasure for all of us in CIDC to work for this aspect of service to this construction industry. Friends, this conference was blessed by His Excellency, Governor of Odisha, His Excellency, Governor of Goa, as well as we were ably supported and encouraged by Government of Odisha as well as Government of Goa. We were also encouraged and supported by our various patrons. We are very thankful to all of them. We are very obliged to them. We are very thankful to all the parties, to all the people who put in efforts, particularly the team of CIDC. They put in Herculean effort to make this conference successful, and that too in this Corona period. So also the team of Dr. Niranjan Swarup. We are thankful to all of them. We are thankful to media people. We are thankful to IT people who made this conference possible and successful. And most important, we are thankful to you. It is you made it possible. Without you, we couldn't have done anything. Friends, thank you very much. Friends, there is a demand that we hold such conferences regularly. People are so enthusiastic. Because such conferences do bring us together. And when we come together, we can synchronize our efforts. India can be made a great nation, a vibrant nation, parallel and shoulder to shoulder with all other developments. Surely we will put in our efforts. So thank you very much. At the end, I pray to God, in this Corona period particularly, Sarve bhavantu sukhinah, Sarve santu niramaya, Sarve bhadrani pashyantu, ma kaschid dukhva bhavet. Thank you, friends. Namaskar.
Good afternoon, ladies and gentlemen. It has been my privilege to remain associated with CIDC and IND-STT for more than a decade now. We need to appreciate the efforts made by the team CIDC and IND-STT to remain innovative, agile, and relentless in their effort for promotion of construction industry in general and trenchless technologies in particular, even in these unprecedented and challenging times. The digital trade show we are all part of today is just one example of their effort to keep the interest and issues of construction industries at the forefront. The COVID-19 has created existential crisis and forced us to bring difficult changes in our lives. Devastated the economy, India is officially in recession now. However, silver lining is just on the horizon. Economy is turning on positive growth rate. Many vaccines are on the horizon. Infrastructure projects have started. Liquidity crunch in the industry is slowly getting relieved. The overall project pipeline is huge. City gas distribution networks has just started taking shape in more than 100 cities across India. Road and bridge projects are humming, and many more infrastructure projects are being announced. I conclude this short speech with a conviction that road to economic recovery is through infrastructure development projects, and industry remains committed to deliver the same. Thank you.
Hello, I am Sunil Garg, Director Technical in Gypsum Structural India Private Limited. I am very glad to see that even in these pandemic times, we have been able to safely continue with the tradition of annual conference and show by making some innovative changes in how we display stands, give presentations, and interact with visitors. This show was even more important for our trenchless industry in these times to show potential customers and stakeholders that projects are again progressing at normal pre-COVID levels after a brief hiatus, and how technical innovations in trenchless field have gained momentum with more people and experts willing to collaborate with each other globally over various online tools. With that note, I thank all the participants. I have been told there are more than 14,000, which would be a record, who have come and shared their experiences and learned about the latest innovations in the field from the presenters and exhibitors. Thank you.
Hello everyone, welcome to the No-Dig India Show 2020. On behalf of North American Society of Trenchless Technology, I'm honored to speak with you and to have contributed on the International Steering Committee for this exceptional program. My name is Craig Vandale, and I'm the General Manager of Alternate Delivery and Business Development for Michaels Corporation's Trenchless Division. I'm also the Chairman of the Board for the North American Society for Trenchless Technology. This past February, I had the privilege of visiting India on a business trip, and during that time, I was able to take part as a guest lecturer at the India Institute of Technology. Over my time there, I was very impressed to see the number of students who attended by the level of interaction, engagement, and excitement from the students who took part. I'm very excited for India's future and with the implementation and development of trenchless technology, and I look forward to watching progressive innovation strengthen India's infrastructure in the years to come. Today, I'd like to talk to you about trenchless technology and NASTT's role in promoting and supporting the trenchless industry, as well as how we can work together to improve our infrastructure here in North America and internationally. Trenchless technology is a progressive engineering process for the installation, replacement, or renewal of underground utilities with no or minimal excavation and surface disruptions, all while limiting social impacts to the public. These innovative methods have been utilized successfully for all underground utilities, including water mains, storm and sanitary sewers, gas mains, electrical and fiber optic conduits. When utilized in urban areas, substantial benefits are realized, including dramatically reducing disruption to vehicular traffic, pedestrian traffic, business activities, residential areas, and environmentally sensitive areas. In most cases, trenchless techniques will demonstrate significant cost savings and benefits for local government, municipalities, and utility owners over traditional open trench methods. Recent advancements in robotics have allowed trenchless technologies to offer never-before-available pipe condition diagnostics, thus providing utility owners tools to more accurately identify and classify infrastructure priorities. NESTT is a society of individuals, public organizations, and private companies with strong beliefs in the practical, social, and environmental benefit of trenchless technology. Founded in 1990, NESTT represents more than 2,000 members throughout the United States and Canada, who all believe in more responsible ways to manage, rehabilitate, or replace our aging underground infrastructure. NESTT's mission is to advance trenchless technology and to promote its benefits to the public and the environment by increasing awareness and knowledge through the technical information, dissemination, research and development, education, and training. We strive to provide a representative voice for all sectors of the trenchless technology industry. For over 30 years, the all-volunteer members of NESTT have presented non-commercial, informative seminars, education, and training about trenchless technologies. Our vision is to be the premier resource for knowledge, education, and training in trenchless technology. And our mission is to continuously improve infrastructure management through trenchless technology. As NESTT continues to grow and take on new challenges, it's important for our non-for-profit society to serve and support our diverse industry partners both in North America and globally. We proudly represent municipalities, public utilities, consultants, engineers, manufacturers, suppliers, trenchless contractors, and academia. We support 11 regional chapters, soon to be 12 with our newest edition, in Mexico, and 19 student chapters at universities throughout North America. We make every effort to reach out to all these groups and share with our communities the latest industry trenchless advancements and our continuing education opportunities. The many benefits of trenchless solutions for today's infrastructure challenges will always be our strengths. NESTT offers multiple in-depth, high-quality courses each year in cities throughout North America, covering targeted trenchless topics like cured-in-place pipe, otherwise known as CIPP, horizontal directional drilling, otherwise known as HDD, gas distribution, municipal sewer grouting, pipe bursting, laterals, and new installation methods. You will find that our course content is of the highest quality as the material is thoroughly peer-reviewed for consensus-based information and non-commercialism. We continually strive to improve the quality of the entire educational experience for our attendees through course evaluations and feedback. In August of this year, we rolled out our virtual component to our Good Practices courses in response to the COVID crisis. We are offering our entire suite of courses in a virtual environment to continue to meet our mission and vision. I feel this is an excellent way for NESTT to partner with India Society and its members by offering these courses. In the coming weeks, we'll be working with the India Society to promote and offer these virtual trainings. NESTT currently has 12 editions of our Good Practices Guideline books. These books serve as companions to our esteemed Good Practices courses and are a valuable resource as standalone references for a wide variety of trenchless technologies. All NESTT publications are peer-reviewed by volunteer industry professionals to ensure that they offer generic and non-commercial information. These books are funded by NESTT as part of our educational outreach program. Since 1990, the all-volunteer members of NESTT have presented on non-commercial information about alternative engineering methods to North American communities. Our latest offerings published in 2020 include pipe jacking good practices guidelines, pipe ramming good practices guidelines, and subsurface investigations good practices guidelines. Another way NASTT can partner with the India Society is by offering our books at a reduced price to all India delegates and attendees. As part of our commitment to reaching all the audiences in not only North America, but throughout the world, we have translated several of our publications. Our CIPP Good Practices Guidelines was translated into Spanish in 2017. Our Introduction to Trenches Technology, Rehabilitation and New Installation books have both been translated into French. Our CIPP book was also translated into Portuguese by the Brazilian Society. We look forward to working with the additional sister societies within the ISTT family on translations and collaborations in the near future. NASTT also offers the world's largest online resource for technical information on trenchless technology. Every paper presented at the NODIG show since 1991 has been archived and is available via search terms in our library. We have over 2,000 papers on every conceivable topic related to our trenchless technologies. Our library is something we are extremely proud of and feel it's an excellent resource that can be used to promote trenchless technology, innovation, and share ideas. For a limited time, NASTT will offer the India Society and its members an NASTT 2021 membership for $100, allowing you to access this impressive library and utilize this knowledge. The NASTT NODIG show is the largest trenchless technology conference in the world, where professionals attend to learn new techniques that will save money and improve infrastructure. The show offers 6 tracks and 160 peer-reviewed non-commercial presentations, including case studies detailing environmentally friendly trenchless solutions and cost savings opportunities for municipalities and utilities. In 2019, there were over 200 exhibiting companies on the show floor with multiple networking events. Attendees can spend quality time with current colleagues, customers, and grow their connections. I would like to personally invite you, the participants of this show, to join the India delegation at the 2021 NODIG show. NASTT will be working with the India Society to develop a special package for this event. For 2021, we are excited to bring an in-person event next spring to Orlando, Florida, in the United States. Things may look a bit different at the 21 show, but the top-notch technical training and networking you expect from our conference will not change. We understand how important the in-person conversations are for sharing ideas, networking, and growing our industry. With that in mind, we plan to deliver a worthwhile event in a safe manner while still bringing you the value you expect from the NASTT NODIG show. We are also currently working on an on-demand online technical program component to reach even more professionals in our industry during these uncertain times. Lastly, NASTT also has initiated the NODIG North Conference. In 2019, the Canadian chapters of NASTT joined forces in Calgary, Alberta, Canada, to put on the inaugural NODIG North Conference. The event was more successful than we could have ever imagined, with over 600 attendees. The need for an expanded regional trenchless conference in Canada is clear, and we are looking forward to returning in November of 21. The conference will be held in Vancouver, British Columbia, and we are currently accepting abstracts for the technical program, and we hope to see you there. In closing, I want to thank you for your time, and I hope you enjoy the 2020 NODIG India show. I look forward to meeting and collaborating with you all in the years to come. From all of us at NASTT, have a fantastic day.
Greetings to all, respected Chairman of CIDC, respected Mentor of CIDC, Honorable Minister from Odisha Government, and the Honorable Chief Minister of Odisha Government, and my dear friend Dr. Swaroop. It's really a pleasure to be part of this validatory function. After the completion of 4 hectic days of 385 speakers and quite a lot of members who had attended and got the benefit, I am here to represent the Board of Directors of ILCE, the Institute of Lean Construction Excellence, which was established over the last 10 years, and it's doing its best to promote the lean practice for one single motto of transforming the construction industry of India and prove to the world that Indian construction industry is in no way inferior to anybody in the world. Saying that, how are we going to achieve it? A lot of mechanization has happened. Now slowly the digitization also is happening. Large volume projects are also coming up. But there is going to be, even though we are a populous country, there is going to be a huge demand and shortage of labor force for executing all these wonderful projects. In our study in the lean practice, it is proved again and again that in the construction industry, there is a considerable wastage of manpower to the tune of 35 to 40%. Very purpose of lean construction practice is to reduce this wastage by applying the wonderful 6 or 7 important tools like value stream mapping, loss planner system and other tools. It has been very well explained by the experts and all the board members on the 2nd of December, and it is good that CIDC is going to upload it in its website for the benefit of the practitioners. When I said about loss planner system or value stream mapping, based on your nature of the project, when you had won the contract and when you are preparing your zero cost budget or initial budget, you please go through and understand how these lean tools can help you to expedite the process of completion as well as reduce the resources. It's not only the labor, you can very well reduce the usage of your equipment, usage of your engineering manpower and other related resources, and the programming can always done with the lean tools in place. Please expose your team members. There are wonderful material available like games and other things which can be used to train your people for the betterment of the completion of the project on time. When a project is completed on time, then you will make your profit. So once again, I am reiterating, ILCE is very much available for the benefit of every practitioner in the construction industry. IIT Chennai, IIT Mumbai, NICMAR kind of institutions are well connected with this process. So make use of this. And I thank CIDC for the wonderful platform which has been given to ILCE for exhibiting its usefulness to the construction. Friends, I wish and I request all the participants, the nation builders and every one of you to learn, understand and connect with the ILCE program and ILCE organization and get transformed. Thank you very much.
Good evening to you. I wish to thank all the delegates, the participants, and the various industry associations and the industries that have participated in the India Construction Week and having made it a grand success. On behalf of Andhra Pradesh Real Estate Regulatory Authority, I wish to thank all the participants for the real estate segment of the Construction Week. As a closing note, I would like to convey a few points to the industry related to the real estate. Real estate is the backbone of the Indian economy, and at Andhra Pradesh Real Estate Regulatory Authority, we have been striving to introduce more standardized methods of construction, trying to build quality of materials into the new projects and ensuring that the quality of workmanship is to international standards. I think all of us understand the importance of using modern technologies and standard products to improve the quality of our buildings and make sure that the life of the building is well protected and the buyers are comfortable and happy to possess buildings constructed by the real estate sector of India. It is very important to note that we have to adopt new modern technologies, more so with the COVID having impacted our businesses. By introducing more and more efficient technologies, it is possible to complete the projects with higher quality at lesser time. So I wish to convey to all the participants and members and the industry that we have to now strive hard to improve the quality of the technologies which we are using, go for more of P-cast and more of elements which are designed for easier use in order that we build better quality buildings and reach the international standards. Thank you once again for attending this construction week and making it a grand success.
Now I'll recite the message from Shri Pratap Jena, Minister, Panchayati Raj and Drinking Water, Law, Housing and Urban Development, Odisha. Honorable Minister says, "It gives me immense pleasure that Construction Industry Development Council, New Delhi, is going to organize an online international webinar on the occasion of India Construction Week 2020 on the theme Reviving Construction Industry in Post-COVID World from 1st to 5th December 2020. Objectives of the event are to provide latest information, knowledge base and guidelines for implementation and meeting the exigencies posed in post-COVID scenario. As construction industry has major contribution towards the employment generation and availability of labor and technology resources, we have to give attention to various aspects of livelihood along with economic prospects. I hope eminent construction engineers, development experts, representatives of national and international forums, other stakeholders from infrastructure industry will provide meaningful information and suggestions to overcome this difficult time. I appreciate the endeavor and congratulate the participants in the webinar and wish the webinar a grand success. That's the encouraging message from Shri Pratap Jena and we thank him for that. I will now recite the message from Honorable Chief Minister of Odisha, Mr. Naveen Patnaik. Honorable Minister says, I am glad to know that the Construction Industry Development Council, New Delhi, is organizing an international webinar on reviving construction industry in post-COVID world on the occasion of India Construction Week 2020 during December 1st to 5th, 2020. Construction industry is a major contributor to Indian economy and also one of the largest providers of jobs. I appreciate the efforts of the CIDC to revive the construction industry during and after the COVID situation. Extraordinary situation demands groundbreaking and intelligent response. With active involvement of the stakeholders, I believe the industry will definitely bounce back within a short period. I wish the endeavor all success and we thank Honorable Chief Minister for this encouraging words and message.
A big hello to all the distinguished participants and the devoted listeners in this very important event, online event rather, organized by the Construction Industry Development Council jointly with Indian Society for Trenchless Technology, supported by the associated organizations in India and abroad. Let me first of all compliment you and state that it's a very commendable initiative taken by this industry, especially in this time of pandemic when we are all struggling to revive the economy all the world over. I feel immensely pleased to associate myself in this event by by the invitation to participate in the valedictory session of this very as far as I'm concerned, my association with the construction industry has been through arbitrations, conciliations and mediations, which I have been doing after demitting office as a judge of the Supreme Court. And I have noticed that the disputes in between the parties, which comes up for a lengthy litigation between the contractors and the main players, takes a long time in spite of a alternative dispute resolution forum. In that experience, I have noticed that very many litigations perhaps can be restricted initially through mediations and conciliation, which I don't think is taken very seriously by the affected parties, and there is a tendency to ultimately lead to litigations where the matter is decided by the arbitrators, which goes up in appeals and further appeals. In my understanding, if an honest intention and initiative is taken by the parties, maybe the duration of litigation can be minimized and reduced to the minimum level, but honesty of purpose is the main ingredient which gets sacrificed. In my experience, I noticed that we are all aware that there are two parties, one who awards the contract. Generally, there are two parties who awards the contract and the other who has to take the payments. Any party who has to make the payment generally has a tendency to drag the litigation, and for some reason or the other, the litigation, even in alternative dispute resolution forum, it gets dragged, because anyone who has to pay will like to drag it, and the other who has to receive it is very anxious because his resources gets limited due to the litigation. I would say that in the pandemic, and not merely in the pandemic, the honesty of purpose by both the sides have to be very seriously deliberated, because I've always felt that when an ordinary litigant is before the court, we generally feel, why do they fight? Because they don't understand to what extent they should yield. So the bottom line, in my understanding, should be the parties should know where to yield and to what extent to yield. And since we are in the summing up session, as a valedictory session, I don't think it is appropriate for me to delve deep into this. But I would say that even when the award is passed, then both parties can have the access of the award, and thereafter also mediation and conciliation process is possible. What I mean to emphasize is that both the parties can come to the negotiating table and can know the views of the arbitrators, or to what extent they have a chance, and they can also see the reasoning. So when coming from the experts and disclosing that bind, that look here is your limitation and you ought to yield. Maybe one mediation is before the litigation and the other is after the mediation. After the award is passed. This is slightly, in my understanding, this is slightly unusual. This is not the practice right now. We all hear the matters, close the box, and then the award is passed. So I would suggest that maybe we can think on these lines, that when the matter gets deliberated, thrashed out, thereafter also maybe a stage can be introduced for minimizing the litigation. So what I'm trying to emphasize and focus through this platform is that the technical aspects, the two players, the one who awards the contract, whether it is public sector undertaking, the government organization, corporates, and the other is who execute the contract through a mediator or by themselves. That is one aspect, and I would confess my limitation that insofar as the technical aspects are concerned, you are more knowledgeable insofar as the technology is concerned, and that is why I am trying to express my view as to how the litigation can be minimized. In maybe some other time you can explore these aspects. The next thing that I wanted to focus and emphasize was that the ethics which we generally ignored is that honesty of purpose and honest intentions are very, very important, which we generally ignore. If the builder, if the construction, and builder, when I say not merely the builder of residential premises, but also in every aspect of the construction, if you have the intention to deliver the project within the time, then the intention should also be to clear the invoices and the bills within the time. And in that, if the honesty is resorted to by both the players, maybe the litigation aspect can be minimized. Of course, I think knowing the human mind, it's easier said than done. But if we keep on focusing on these aspects, maybe little bit improvement can we can do in improving the resolution of disputes. For an ordinary ordinary investor, if they do it in a residential premises and they do not get delivery of possession within the time, and in spite of the clauses in the agreement that they will be compensated by adequately by the terms and conditions for the delay, it gets enmeshed into the litigation. So the entire scenario which I've noticed is ultimately things very frequently gets enmeshed into the litigation, and when there is no litigation is also created. So we have to make an endeavor that as a matured players, we must try to reduce this as much as possible and yield to the extent which you think is reasonable on your part. The focus should be on the reasonableness of the active players. I think for summing up, I do not know, because I did not have the occasion to participate in all the sessions, but I guess I do not know what are the theme of the subjects in each conferences have been dealt with. In absentia, these are my random views on the conference, And I would not say more except wishing all the best to the players, to the participants in contributing not merely in the pandemic, and I'm hopeful the pandemic would be over, we would reduce to the normal times if we succeed in overcoming this demon of COVID by locking them into the
Welcome to everybody to this valedictory function of ICW 2020, and my special warm welcome to Honorable Justice Gyan Sudha Mishra, retired Justice of Supreme Court of India, Dr. P.S. Rana, Chairman CIDC, my other friends who are here, and a very, very big thank you to the state governments of Odisha and Goa, where Honorable Governor himself has conveyed his message. Honorable Chief Minister of Odisha and Goa, they have conveyed their best messages. And of course, Honorable Minister of Urban Development of Government of Odisha, they have all conveyed their best messages. Thank you all. I also thank almost 340 speakers who took their precious time to send us wonderful passages which were displayed during last 5 days. Over 10,000 participants, so many sponsors. I must tell you that this was the biggest event that we have ever had. And this is the success which we are enjoying now. The purpose of this particular event, as all of you are aware, was to find a blueprint. And I must tell you that this journey is just beginning and it is not the end of it. We are going to be setting up now a working group comprising of all the honorable members of the steering group, and we should be basically elaborating on the recommendations, compendiums of which will be prepared, and the work has already begun on that. They will be sent to various stakeholders. That basically involves the state governments, the union government, the industry, and the experts for that matter, and anybody and everybody, but especially to my colleges, institutions, and the young engineers who are going to be taking over the construction and infrastructure industry from now. We have been putting focus on many of the emerging technologies, the new areas, and especially I have to mention that the technology which is known as trenchless technology and so very vital for the subsurface infrastructure. We have had overwhelming support from almost all the nations and experts from everywhere. They came out and they spoke about it. I will also talk about the lean construction techniques which are going to be economizing the functioning of construction industry. And these are all the things that we deliberated. And the intent was simple as to how to make our industry far more capable, far more competent, and especially in these difficult times, how to make the operations far more economical. Construction workers are our backbone. Almost 4 crore construction workers. They are engaged with the construction industry in India. We have to make sure that they should be trained, they should be tested and certified. And I am so happy to inform you that utilizing the e-techniques, we have been continuing with the work. As a matter of fact, on pro bono basis, many of the construction workers have been coming and getting themselves tested for the skills that they have acquired, which is a very satisfying science. My appeal to all the construction companies in the country is to ensure that a large number of the construction workers and supervisors, including the engineers, they are put on the path of education so that they basically grow, they work out the kind of things which are going to make our functioning so much efficient, and CIDC definitely is going to be helping out on such initiatives. Let us look at the emerging technologies that have come out now and kind of wonderful work which many of our youngsters are talking about and the work that they have done. Should we not put them in adoption? And that is something which is going to be the essence and purpose of this particular deliberation that we have had. We'll talk about the financial issues, especially the NPAs that are troubling the banks and everybody at large for that matter. We are in dialogue with Indian Bank Association, and new compendiums are being prepared which are being sent to revise the procurement processes. Disputes, they have been a bane to our industry, and plethora of disputes are existing as of today. It is infructuous, and I am so happy that Justice Mishra is with us today, and we are now working on online dispute resolution techniques which are going to be useful for everyone and going to be far more economical. Under the banner of Construction Industry Arbitration Council, we shall be taking up this particular thing more vigorously, and now that we have a portal, this is going to give us a chance to really help resolve all the disputes that we can. May God help us all on these things. Let us look at the kind of professional grooming of our young persons. And Engineering Council of India has been working relentlessly to make sure that our engineers are imparted continuous education. So my appeal to all the colleges and the students is, please come and try to learn new techniques, make the functioning of the industry far more effective and definite, and that is where basically we'll